Hello and welcome to this comprehensive course on building a URL shortener using modern technologies. I am Ahmed, a developer with 8 years of experience. Throughout my journey, I have learned and grown enormously. Now I believe it's time to give back to the community what I have learned. This course won't be your typical course, as you won't just learn how to do things, you will learn how to do them the right way, incorporating best practices and expert recommendations. Embracing the concept of learn by doing, I have found that a URL shortener serves as the perfect example to demonstrate several important technologies. So let's begin by going deeper into our course content. The concept of a URL shortener is quite straightforward. It transforms long URL, which may contain important parameters, into short URL that are less overwhelming for users. In essence, a URL shortener is a simple concept that can be easily implemented. The process involves the user creating a short URL, publishing it, and then allowing others to access it. Each visit will be logged into the database, and that's it. Now we are going to talk about the core of our application, which is Node.js. Node.js allows you to use JavaScript for server-side logic, ensuring a consistent language across both the backend and the front end of your application. Secondly, Node.js non-blocking and event-driven architecture makes it an ideal choice for building scalable and high-performance applications that can handle a large number of concurrent connections. Finally, Node.js uses NPM ecosystem, which offers a variety of libraries and modules to simplify the development process of your application. While Node.js uses JavaScript, in this course we are going to use TypeScript. TypeScript adds a static types to JavaScript, which helps catch errors early in the development process and improves your code reliability. Also, TypeScript provides better auto-completion, code navigation, and refactoring capabilities in popular editors, which can boost productivity and ease the development of your application. Finally, TypeScript's type annotation and interfaces make it easier to understand the structure of the code, increasing the maintainability as your application grows. Now, to store our data, we are going to use Postgres. Postgres is a robust open-source relational database with a strong focus on performance and reliability, making it an excellent choice for our URL shortener. Also, Postgres offers a high level of scalability, allowing your application to grow and manage increasing amount of data and concurrent user easily. Finally, Postgres is an ACID compliant, ensuring data consistency, integrity, and reliability in your application, even in cases of hardware failure or crashes. And to integrate Postgres with Node.js, we are going to use Knex. Knex is a powerful and flexible SQL query builder and schema management library for JavaScript, allowing you to easily interact with your Postgres database in your application. Also, Knex supports multiple database systems, including Postgres, ensuring that your application can be easily adapted to work with other databases if needed. Finally, Knex provides built-in support for database migrations and seeding, enabling you to manage changes to your application's database schema and populate it with initial data efficiently. Now for our HTTP library, we are going to use Koa, which is a lightweight modular web framework for Node.js designed by the team behind Express that makes it easy to build and extend server-side logic of your application. Also, Koa uses a middleware-based architecture which allows for greater flexibility and customization in handling requests and responses in your application. Finally, Koa has a built-in support for async and await, simplifying asynchronous operations and improving code readability and maintainability in your application. Now that we have introduced the key technologies that we are going to use in this course, we are ready to dive into the development process of our application. As we progress through this course, you will gain hands-on experience working with these technologies, and you will learn how to implement best practices to ensure that your application is efficient, scalable, and maintainable. By the end of this course, you will have a fully functional application and a solid understanding of how each technology contributes to the overall success of the project. So, without further ado, let's get started on this exciting journey together and build an amazing URL shortener service from scratch. So, see you in the next video. So after we finished the introduction about our course and the introduction about the URL shortener that we are going to build, we will start this section by setting up our development environment in our machine. So we will start by opening Visual Studio Code, and in the inline terminal within Visual Studio Code, we are going to check that we have both Node and NPM installed and recognizable in our system environment variables. We will start by running the following command, node -- version. As you can see, I have Node version 18 installed in my machine. If you have any Node version 16 or higher, or even 14 or higher, you should be okay. The next thing that we have to check is npm -- version. As you can see as well, I have npm version 9 installed, and now we can continue to the next section. I will clear my terminal using the clear command because I like always to keep my terminal clean for my next session. Then I will close it and I will go to the extensions section of Visual Studio Code, and I will install the first, and you should install actually the first extension, which is Prettier. Prettier, it's a very famous formatting extensions for Visual Studio Code. The next extension is ESLint. It will check your syntax errors and highlight them. This will make your development journey easier and more enjoyable. The next extension is Code Spell Checker. I find this extension very important because I think that your code that you are going to share with your coworkers is a representation about yourself. I think a clean code should be logically correct and also grammatically correct as well. The next extension that we are going to install is VS Code Icons. It's a small cosmetics that you are going to add to your Visual Studio Code that will make the files and folder sections more visually appealing to you. This will make it easier to find files and folders within the file sections in your Visual Studio. Now that we have installed our extensions, we will go to the desktop and create the folder that will hold our project. We will call it URL Shortener. Now we will go to Visual Studio Code and open the folder that we just created. We will go to the desktop and select the folder and open it. Now we will open the inline terminal within Visual Studio Code and start by executing the first command, which is npm init-y. This will initialize the package.json file within our project. The package.json file will contain the list of dependencies or the list of libraries that we are going to include at our project and we are going to use. It will also include a list of scripts that will be predefined by you to make running the most common commands much easier. We will learn about that during the course. Next, we should install the libraries that we need in our project. But I won't be installing any dependencies until I need them. So I won't execute this long and boring install command. I will wait until I need the library, then I will install it. So you can understand for what I'm using each library exactly. So we will clear our terminal once again, and we will start by installing TypeScript. So we will write the following command, npm install -d. The -d is very important because it will tell npm that those libraries are dev dependencies, which means they are development dependencies. The development dependencies mean that they are not required in the production. So because we are converting TypeScript into JavaScript, and in the production we are only using the JavaScript files, we don't need the TypeScript in the production. We only need it during the development. That's why we are specifying that those TypeScript libraries are only for development and not for production. We will start by installing the first library, which is called TypeScript. The second library called tsnode, which will allow us to run any TypeScript file without compiling it. The third one is types/node, which is the library that holds all the types declaration for Node. We will wait for npm to install our packages. And after npm installs our packages, we will see that we have a new section in our package.json, which is the dev dependencies. This dev dependencies will have all of our dependencies, each one with the installed version. Now we are going to execute one more command, which is npx tsc-init. You have to pay attention that I am using here npx and not npm. npx have a very useful scripts for initializing a number of different libraries for Node.js. So in npx, we have a script called tsc, and we are passing a flag to initialize. So when we run this command, we will see that we have a new file created at our root directory called tsconfig. This file will hold all of the configurations for our TypeScript compiler. Now, this tsconfig file seems pretty overwhelming, especially for beginners. And in this file, we have a lot of variables that we can change. But actually, we don't need to know about any of them right now. We are only going to change 2 or 3 of them to match our coding style. So we are going to store all of our source code related files in the src folder. So this src folder will hold all of our TypeScript files. And we are going to create another folder which we will call a build folder. This build folder will hold all of the compiled JavaScript files. So we are going to take the files from the source folder, compile them into JavaScript, and store them in the build folder. To do that, we are going to change a couple of parameters in here. The first one is the root directory. We are going to uncomment this line and specify the root directory as our source folder. Then we are going down and searching for another one called the out directory. I'm going to search for it with you. Okay, here it is. The out directory, we are going to specify it as the build. The third thing that we should do is to tell the TypeScript compiler to ignore any file that is not in the src. The final thing that we should do is to tell our TypeScript compiler to not compile any file that is out of the source folder. We will do that by defining an include parameter. The value for this include will be the source, basically. So we are going to specify that include only the files that are under the source folder. By that, we will be finished by our TypeScript configuration, and we can test our TypeScript configuration right now. We are going to go to the source folder and create an index.ts file, and we are going to create a simple function, which we will call it sum, it will take number 1, which is a type of number, and it will take number 2, which is also a type of number, and it will add both of them. Then we are going to console.log the sum of 2 and 4. Now, to execute this file as a TypeScript file without converting it to JavaScript file, we can use a library that we installed earlier, which is the tsnode library. But to install it outside of our project in the terminal, we have to install it as a global dependency. We are going to do that by executing npm install -g. The -g will install it globally for all of your machines, so you can always use the tsnode command. So we are going to specify tsnode. After this command finishes, we will have the tsnode command available in our terminal. So we can execute tsnode and then specify inside the source folder we have index.ts. If we executed the following file, we will have the number 6 printed, which is the sum of 2 and 4, which is perfect. Now we are going to compile this TypeScript file into JavaScript. And to do that, we are going to execute a very simple command called tsc. But to do that, we have also to install a second library, which is the TypeScript library. Although we installed them in our project directory, we have to install them globally to be able to use them in the terminal. So after we installed our TypeScript library globally, we can now safely execute the following command tsc. After we executed the following command, we can open our build folder that we specified earlier, and we will find the index.js file that will hold our JavaScript code. If we compare the two files together, you will find them very similar, but the JavaScript file will not have any type declaration as we have in here. We can execute our JavaScript command by running the following command, node, and we will specify now the build folder, then index.js, and we will find the same result from our JavaScript file. Now, we made sure that our TypeScript compiler is working perfectly, and we also have finished setting up our development environment. So, see you in the next video. Now, our final library that we have to configure is the ESLint library. Although we have installed the extension for the ESLint in our Visual Studio Code, we need to install that extension in our project in order for this extension to be able to validate our project correctly. We are going to do that by using the same npx package and execute the command eslint-init. This script is very useful because it will install all of the required packages for ESLint and also create a custom config file for our ESLint. So as you can see, it's asking need to install the following packages, ESLint. We will hit yes. Then the script will start to install our ESLint base library. After that, the library will start to ask us a couple of questions about our code style to be able to configure the config file for us correctly. So how would you like to use ESLint? We actually prefer the final option to check syntax, find problems, and enforce code style. Then what type of module your project is using? We are using the import-export. We are not using React or Vue.js, so we are going to select none of these. Our project is using TypeScript, so we will select yes. And our code run as a node instance, not in the browser. Then we are going to use a popular style guide. You can define your own coding style, but it's recommended to use a popular style guide. And I am going to use the standard style guide for this course. Then we want our config file to be as a JavaScript file because it's easier to change anything on it on the future. After that, ESLint will work and install all of those libraries for us, each one with its correct version. So we will hit yes. We need to install them via yar or npm or pnpm. We are going to install them via npm because it's the package manager that we are using in this project. Then we have to wait until npm finishes the installation of our packages. Now, npm finishes the installation of our packages. We can see if we go to our package.json file, we can see that we have ESLint installed, ESLint config standard with TypeScript, ESLint plugin import, ESLint-n, ESLint promise. All of those libraries are required for the ESLint extension to work correctly with our project. Then we will find that there is a new configuration file created in the project directory called eslint.js. We are specifying in this file a couple of parameters for the extensions. For example, we are browser equals to true. So as you can see in this configuration files, we have set a couple of parameters for the ESLint to work correctly with our project. In this file, we can specify any rules that we want to specify or change with the ESLint extension. We will go through that in our course. We don't have to worry about it now. In this video, we covered the topics of setting up our project environment, testing our TS or TypeScript compiler, installing ESLint and configuring it, and starting with our index.ts file. In the next video, we will talk about our database connection and starting up our database drivers and database connection. Thank you. In this video, we will start to establish our database connection, and we will learn how to link our Node.js application to our database. So we will go to the pgadmin, which is the management tool for Postgres, because we are going to use Postgres in this course. So we will open the pgadmin, which will come when you install your Postgres from the website. So you should have it on your machine if you have installed Postgres. Then it will ask for our master password, which we specified during the installation process. In my case, I have set it to root. So we can open the Postgres. Then we will open the list of servers that we have, and I also have specified this password to be root. Then we will have the databases, and I have only one database, which is the Postgres database. This is the default database that Postgres creates by default. So we are going to create a new one, and I am going to call it URL Shortener. And I am going to save that. This is my database that I am going to use in my application. So I will minimize my pgadmin and I will open my Visual Studio Code. Then I am going to install the required dependencies to link my Node.js application to my database that I just created. So I will start by npm install. And this time I won't set the flag -d because those dependencies are required in production. As you can see, all of the dependencies that we installed earlier are dev dependencies. Right now we are going to start with our production or the regular dependencies. So I will start by installing pg, which is the Postgres driver for Node.js, and I am going to install Knex, which is a query builder for Node.js. So while they are installing, I will explain in a nutshell the differences between pg and Knex. pg will take a raw query, send it to the database, and it will return to you the raw query that Postgres returns. Knex, on the other hand, will help you build your query in a more readable way, and it will parse the output of the Postgres to you as an array, as a JavaScript array or a JavaScript object, and so on. So it will help you a lot. And Knex can actually connect to multiple databases like MySQL, Postgres, SQL Server, SQLite, and so on. So you can write your application once and run it on multiple databases at the same time without changing anything. Knex will handle any changes between the databases. So to set up our next instance, we will go to our source folder and create a new folder called config. This folder will hold all of the configurations for any library that we might use in the future. Our first library that we need to configure is Knex. So we will create a new file called Knex.Js. In this file, we are going to import Knex from Knex. But we are going to import it as capital letter because it's the library. Then we are going to create an instance, which is Knex in small letter equals Knex the library, and then we can start specifying the configurations for this library. So first of all, we should specify the client, which is in our case, PostgreSQL. We can in here set it to MySQL or SQL Server or SQLite or any other SQL database that is supported by Knex. The next parameter that we should specify is the connection parameter. The connection parameter is actually an object that have multiple values for our application. The first one is the host. The host in our case is localhost because the database is in our machine. Then we will specify the port, and we will set the default port for Postgres, which is 5432. Then we are going to set the user for our database, which is in our case the default user, which is Postgres. Then the password, which I told you about it, which is root. And then the final one, which is the database that we created, which is the URL shortener. Then we are going to format our file using Shift, Alt, and F to make our file look nice. Then we have to make sure that our database is actually connected because connecting to the database required a couple of seconds. So for example, if you started your application and allowed users to make requests to your application before your database connection get initialized, you will face some errors in the production. So we are going to create a function, we are going to export it so we can use it from other places, which is on database connect. This function is an asynchronous function that will return void, and what this function will do is that it will execute a very simple query to the database to make sure that the database is responding to us. So the query that we are going to execute is next.row. We use the row function to execute any row query to the database without using next query building. So we are going to select the one, and that's it. This is our query actually. This query will return only one, and the only purpose of this query is to make sure that our database is actually connected and we did not face any issues with our database connection. Then we are going to export default our next instance that we created earlier, and that's it for our next configuration file. Then we are going to go to our index.ts file and clear the code that we created earlier. And then we are going to import Knex, the instance that we created, from our configuration file rather than importing it from the library. Then to make sure that our database is connected, we are going to we will import Knex, and we will import a second thing, which is the function that we created. We can import any function which is exported as a constant using the curly brackets in the import statement. Then we will call on database connect function, and we will call the then function to it because it's a promise. Then if everything went okay, we will log console.log database is connected. Then we will specify the catch statement for our database. We will grab the exception, which is specified by E, and then we are going to log console.log error with database connection. Then we are going to log the error that we encountered. Then we formatted our code and we are ready to run our code. We can run our code using the command that we used earlier, which is tsnode, then source/index.ts. As you can see, we received database is connected, which means that all of our configurations are correct and we are ready to move into the next step. Now that we have finished our database connection establishment, I actually noticed in the previous tutorial that the font in the Visual Studio Code was a little bit small. So I can actually make it bigger by pressing on Ctrl and plus. This will make it more visually appealing to you and will make things clearer to you. So it's good that I noticed that before we got into the serious coding. Now we should, although our database connection is fine, we should never leave our database credentials publicly in the source code. This is actually, first of all, a security vulnerability because we are going to push our code to GitHub. So we should never store any secrets publicly in the code, and we should store them in something that we call environment variables. And there is actually 3 reasons why we are using environment variables. The first one is that, let's say I'm working on the code and there is another developer is also working on the code. We are both pushing our code to GitHub. I have, let's say, the port 5432 for my database, and he have the port 6000 for his database. So every time he is going to pull my code or push a new code, he is going to change the port, and this is going to create conflicts between us. So my database configurations should be held in a place that we don't push to our version management tools. The second reason that we should use the environment variables is that it's a security vulnerability, as I told you, to store any of those variables publicly in the code, because your source code might be in someone's hand and you don't trust that one or that person. So you should never leave your source code secrets in the code. The final one is because when we are going to deploy our application to the end server, we don't want to edit the source code in the target machine. We don't want to change the source code there. Most of the servers don't have even a UI. We are going to edit them through the command line, which is a very painful thing to do. So we should keep it simple, and we should store everything in an environment variables for the reasons that I told you. So to use environment variables, it's actually pretty easy. First of all, we are going to clear the terminal and install a new package called .env. This is a very useful and small package that we are going to use. Then I am going to create a new file called .env. This file will hold all of our environment variables that we will use through the application. Our first environment variable that we are going to use is node.env, which will specify the current environment that we are working with. So in our case, it's development. We can specify this as staging, production, or development, but it's very important to set this environment variable. It's a common practice to define it, and many of the libraries will relay on that or relay on this environment variable. Then the second parameter that we should specify is our DB host, which we will set to localhost. The third one, which is our DB port, which is 5432, which is the default port for Postgres. I will make the files one by one to see the differences. So we are going to move the port. Now we are going to move the DB user, which is Postgres. Then we are going to move the DB password, which is root. And finally, our DB database, which is URL Shortener. Now, in order to use this file in our application, we are going first of all to import this library, which is .env. So we are going to do that by writing the following import statement, which is .env/config. This line will actually load the content of this environment variable into our application. Now, to use those environment variable, it's important to note that this import statement should be the first line in your application. So you can't just leave it under that, because by the time that we reach this operation, we would be finished by our next configuration, instance configuration. And the config file won't recognize any environment variable. So it's very important to leave our .env/config file or .env/config the first line of our application. Now we will go to our Knex.Js, and we are going to change every variable with the environment variable that we created. So our host will be changed to process.env.dbhost. Our port will be changed to process.env.dbport. And our user will be changed to process.env.dbuser. Our password, the same thing. And our database is the same thing. Now, we have an error in here because the port needs to be a number, and all of those variables are actually a string. So we have to cast this variable or this value to a number. And by that, we will get rid of the annoying error that we were getting. Now, it's okay and everything is working in here, but I want to give you a tip about destructing an object in Node.js. So you see in here that we are always specifying process.env.the variable name, process.env.variable name, and so on. We can eliminate all of this noise, which is the process.env, by doing the following. We will specify constant and open curly bracket and then set our object that we need to destruct. Then we are going to move those to here so we can access them directly without needing to mention process.env each time. Now we can replace them and remove the process.env, and you will find it will work perfectly. This is really a cleaner approach to destructing multiple variables from the same object. Now we are going to go to our index.ts file, and we are going to run our TS node again with our source/index.ts and check our database connection. As you can see, our database is successfully connected and we don't have any problem. To prove it to you, I am going to change the port and rerun again. As you can see, we received a connection error because the port is invalid. So we will correct our port and then run it again. And as you can see, everything is okay. So in this tutorial, we covered the environment variables, we added the library, we created our .env file, and we added the configurations in our Knex.ts file. So now that we have established our database connection and we have successfully used the environment variables to connect to our database, it's now the time to talk about another subject, which is the database migration. The database migration is the process of managing the incremental changes on the database schema over time. It allows us to version control our database schema and to make it easier to maintain the database and ensure that everyone working on this project is using the same database. So the theoretical part is difficult for anyone because there is not really an example. So I will give you an example. So let's say we have a users table. In the users table, we have a username and a password. Then we deployed our application to the end server, and we are using our application. So during our development, we discovered that we actually need the email of the user. So we added the email column to our database. Now, next time when we are deploying our application, how would we know if this version or this instance of the application is working with the correct database? How can we validate if the database have the email column or not? So the way that the migrations have solved the issue is that we will create the first migration, which will create the users table with a username and password. Then we will create another migration, which we will specify that in the users table, we are going to add the email column. So whenever the system starts, the system will check if there is any migration that he did not run before, the system will run it. So the first time that we run our application after we add the second migration, our system will run this migration and will have an up-to-date database schema. Now, we are going to use Knex to manage our database migrations. And to do that, we are going to install the Knex API with npm install -g because we want to use the Knex API globally. And we are going to install Knex as a global dependency. Then we are going to execute the command Knex init -xts. This actually will create a Knex configuration file specifically for TypeScript. After we executed this command, we find out that we have a new file in our project directory. As you can see, this file is very similar to the files that we created in our Knex instance file. So as you can see, remember when I told you that multiple libraries actually relays on this node.env environment variable? Well, Knex is one of them. It's actually checking your environment variable, node.env, to check whether it should run this one, or this one. Now, we don't have a different configurations between the development, staging, and production database instances. So we are going to copy the same staging configurations and put it on the development configurations. Then remember, one of the main benefits that we use our environment variables is that everyone can access those variables within our application without changing anything. So in the first line in here, we are going to import .env/config. This will add the environment variables to our Knex file, so we can have the same exact configurations as we have them in our Knex.ts file. Now you will be, maybe you are confused because we are redefining the same configurations twice in our config/Knex.ts and in our Knex.file.ts. That's because this file will be used internally within our application, while this file will be used through the Knex CLI. So to create a new migration, for example, I will run Knex migrate make, and I will provide name of the migration. This command doesn't know about our custom config file that we created. It will only recognize this predefined file. So we should rewrite our configurations. But because we have specified our database environment in an environment variables, we can easily copy this connection object and place it in all of the different configurations. Now we are getting an error because we did not actually define those variables, because in this file we destructed them at the beginning. So we will just add this in here, and voila. Now we have everything working in our Knex file configurations. Now we can easily run this command, and we will run to create a new migration. We should first create the migrations folder, which is called migrations. Now we will go to Knex, and we will execute the command migrate make, and then we are going to specify the name of the migration, which is create first. I will call it for now first migration. Then I am going to specify the same flag that I specified before, which is -x and then ts, to specify that this is a I need a TypeScript file. As you can see, we have a new file in here, which is called first migration with a timestamp. And in this file, we have two functions. The first one is the up function, which in here we are going to create the tables, columns, and so on. And in the down function, we are going to drop the tables or drop the columns, and so on. So the up command will run the migration, and the down command will reverse anything that the up command have did. As you can see in here, in this function, we have an X instance. This is a different instance than what we provided in our config file. This might seem confusing for you at first, but you have to understand that the Knex file and the Knex file CLI commands and the migrations are separated from our application. They are even outside our source folder. So they have a different way of, let's say they have a different configurations. So because we have specified all of our database params in here, when we run our migrations, Knex will actually inject the correct Knex instance to our up function, so we don't have to worry about that. So in the next tutorial, we will write our first migration, which is the users table for our URL shortener. So see you then. Now, after we have created our first migration, we can start by creating our users table. We can do that, and we will start by the await keyword, because this function is actually an async function. And the table creation process, which is provided by Knex, is actually an async operation. So we can put the await operation on it. So we will start by writing Knex.schema. Then we will use the function create table. Then we will specify our table name, which is users. And for the next parameter, it's actually a callback. This callback will have one parameter, which is the table builder, which we can build our table through it. So our table builder, we can specify the columns in our users table. So the first column that we have is actually the ID. When we write the table and then we write the dot and we see the autocomplete, we can see that we have all of the data types supported by the database. So we have a date, we have integer, we have Boolean, binary, a big integer, and so on. For the ID, we are going to use a special data type called increments. This increments data type is actually an integer that will increment with each new record. We are going to call it ID. Then we are going to set this column as the primary key for this table. Then our second column for this table is the username, which is actually a string. So we are going to call it username. Then we are going to set a constraint for this column, which is the unique, because we don't want two users to have the same username. Then for our next column, we are going to store the password. So at first we can leave it as a string, and we can specify a constraint for it, which is not nullable. And we should probably do the same for the username, which is not nullable. Notice that you can chain the constraints easily, and you can set multiple constraints for the same column. For the password, we are not going to store raw passwords. We are going to store hash passwords, and hash passwords are long. So actually the string column won't be enough for them, and we will face errors in the future. So we are going to change that into text, because the text can hold more than the string. The next columns that we are going to add are the timestamps. The timestamps are usually something like this, which is a date time. We will call it created at, and then we will set the default value for this column, which is to be next.fn.now. This might seem a little bit confusing, but we are just creating a date time column, which will store the date and the time, and we are going to set a default value for this column to be now. We are setting the default value using a ready function from Knex called now. Because as you can remember, I told you earlier that we can use Knex with multiple databases. So for Postgres handles the now function differently than MySQL. So Knex knows that. So actually this function will handle, if we run our application with Postgres or MySQL, it will change accordingly. Then the second timestamp is usually the updated at. So we can always know that when this user was created and when this user was updated. But Knex have a very good have a good shortcut for that, which we can specify timestamps, and this will take two parameters. The first one is asking us whether we need to use timestamps, which is true, and we are going to default them to now. By using this line, we can remove the following two lines, because this line will actually create the two lines for us. Now, we finished our users table. This is the schema for our users tables in the up function. As I told you earlier, for each table that we are going to create in the up function, we have to drop it on the down function. So we are going to mention the await keyword again, then next.schema. Then we are going to use the function drop table, which we are going to drop the table users. By this, you wrote your first migration successfully, and we can run our first migration by executing the following command: next migrate latest. You can see that we ran one migration in one batch. So if we went to our pgadmin and we went to our URL Shortener database, to our schema, to the public one, and we refreshed our tables, we can see that we actually now have 3 new tables. We can check our users table. So we can see that in our users table, we have ID, which is an integer. We have a username, we have a password, we have created at, and we have updated at. We also have 2 tables that belongs to Knex. So the first table is the Knex migrations. Remember how I told you that the application will check if he executed this migration before, it will not execute it again. So as you can see in here, we registered in the database that this database already have the first migration. So when the next time, if we try to run this migration again, which is the next migrate latest, this command will give you already up to date. Because we only have one migration in this directory, and if we went to the pgadmin, we will find the same migration existing in our next migration table. So we know that this migration have been already executed on this database instance, and we don't have to execute it again. Now, if we want to execute our down function, we should roll back. So we will execute the next command, which is migrate rollback. This will roll back the migration that we created earlier. So if we refresh our database tables, we will see that our users tables is gone because we dropped our users tables in the down function, as you can see in here. And if we refreshed our next migration rows, we will find that the first migration that we have is actually deleted from the database. So if we went back and executed next migrate latest again, we will find that we actually can execute it and it will not give us already up to date. And if we refreshed our pgadmin in here, we will find it again in here and it will not be executed again. If we refreshed our tables in here, we will find the users tables back again in our database. So for now, I have more tables to add to this function. So I'm going to roll back this migration, and I will in the next video I will write the migration for the URL tables and for the visits table. So stay tuned. Now, after we have finished and tested our users migration and users table creation, we can start with our URLs table, the table that will hold the URLs for us. So we will start by creating a table, which is the URLs table, and we will specify our table builder, and then we will start specifying our table. So the first parameter that we will have is the ID. In this case, the ID won't be a number. It will be a string, which we will call an ID. And we will set it as a primary key. The reason for that is we are going to use the ID as the shortened URL. So let's say we have the following domain. I'm not able to write now. So let's say we have this shortened URL, which will stand for a very long and boring URL. So this is actually the URL ID. So we can't use the same increments ID because it's not logical to have the ID will be like 1, 2, 3, 4, 5, 6. This will make scrapping our whole database is a very easy operation because someone can just do a for loop between 1 and a million and will be able to get all of our URLs and store them somewhere else. And we don't need that. So we can't use the increments ID. We are going to use the ID as a string. And the second column is the actual URL. So we are going to store it as a text, which is the URL. And we are going to set it to not nullable. And the third parameter is actually the user ID. We are going to create a foreign ID to the users table. So the ID of the users table is mentioned here as increments, which is actually an integer. So we can set this column to integer. We will set it as user ID. Then this column will reference the ID in table users. And when we want to delete the users, on delete cascade. So as you can see, and we want to set this as not nullable as well. The first one is the timestamps, as we did earlier, and that's it. As you can see, the operation or writing queries in Knex is very easy and intuitive. You can just stack them up. It's very easy. You don't have to write raw queries. It's a programmatically good approach to do that. So you will see through this course the benefits of using Knex. So the URL schema is fine, but we haven't set a default value for our ID. For our ID, we need something that can generate for us 4, 5, maybe 6 characters, random characters, that we can use them as an ID. Because remember, we are a shortened URL service. So we don't want our URL to be long. We want it short, but also randomized. We don't want anyone to be able to scrap our own or the whole database. So to do that, I am going to go to PG admin, and I am going to experiment with some queries that I want to test. So to do that, I'm going to refresh everything so you can see my entire workspace. I haven't run any migrations on my database yet because we rolled our migrations back. So I will go to my database, and in here I will open the query tools. I am going to test some queries in my query builder or query tool, so I can figure out how can I generate a random set of numbers that I can generate, that I can use in my column as a default value. So first of all, to generate anything random, we have to use the random function. So let's check the output of the random function. So as you can see, the random function will generate a number between 0 and 1. This is actually not very helpful for us, but we can actually use something called MD5, which is a hashing function. So we can, the hashing function, which is called MD5, can take any text. So let's say hi, and if we executed this, this query, you will see that you will have this random characters in your, as an output. So let's take the output of the random function and cast it to string or to text, and then see the output. So as you can see, we have generated a random set of characters that would be very suitable as an ID for our URL. The only problem with this approach is that this output ID is very long. And because we are a short URL service, we can't use this long URL, because what's the point of using our services? So we are going to use a second function, which is called substring. This substring function, we can define that we need from 0, 4, 7. So we are actually taking the random, casting it to the random number and casting it to text, then hashing it as an MD5, and then taking the first 6 characters of it. If we executed this one, you will find the ID now is very reasonable and short, and it's actually unique and unpredictable. So it's perfect in our case. So we are going to copy this function that we created or generated. Of course, there is multiple ways of approaching and generating random ID, but I find this way very simple and easy to explain, so it will work great for our course. Maybe in the advanced course, I will highlight on a more advanced way of generating that. So let's copy this, and we will go to our migration, and in this ID, we are going to set default to. Then in the default, actually, I'm not going to set a raw value. I'm not going to set it to hi or anything. I'm going to set it to a query. So we will use next.row. We are going always to use this function to set to pass raw queries. Then I am going to pass the function that I tested before. So for now, each new column that is, each new row that is going to be created in the URLs table are going to have a random ID, which is a 6 random characters. So the final thing that we should add in our tables is the visits table, because we want to log all of the visits for each URL, so the user can know the traffic to his shortened URL. So we are going to create a table which we will call visits, and in this table we are going to specify multiple things. So for the ID, we don't care about someone scraping the database, because only authenticate each user will know his visits only. So we don't care about this. So it's okay to use the increments ID. Then we are going to make a foreign key for the URL. So when we created a foreign key for the users, we created the foreign key as an integer, because actually the ID in the users is integer. But the ID in the URLs is a string. So in here we have to create the foreign key as a string also. So we will create it as URL ID. Then this will references the ID in table URLs. And on delete for the URL, if we delete any URL, we should delete all of the visits associated to it. We don't have to store this information anymore. So we will specify on delete cascade and set it as a non-nullable field. Then the next column is the IP. We should store the IP of the user that visited this URL. The next column is the timestamps. We should be able to know in what time this user visited this URL. Now, we have to align our down function with our up function, and because we created the users and the URLs and the visits, we have to drop them. So we have to drop the table URLs and then drop the table visits. But actually, this order will cause a problem for us, because when the database tries to drop the users table, it will actually find that the users table is associated to the URLs table via this foreign key. So it won't allow us. The same thing will happen to the URLs tables. It's also associated to the visits table. So to solve this problem, we should reverse the order. So we will drop at first the last table that we created, which is the visits table, because this table is not associated with any other table. Then we will drop the URLs table, and then we are going to drop the final table, which is the users table. By that, we will not have any problems while executing our down function. Now we are ready to execute our migration. So we will run next migrate latest. Now, as you can see, the migration have been executed successfully. If we went to our database and refreshed our tables, we can see that now we have a users tables, visits tables, users tables, and URLs tables. In the users table, we have the ID, username, password, created at, and the updated at. In the URLs, we have the ID, URL, users, created at, updated at. And in the visits, we have the columns that we specified as well. Then let's go and try our database basically. So to be honest, I want to try the function that we created for the URLs ID. So we are going to go to the users, all rows, and I am going to create a new column. The username, I will leave it as test. The password is test. And I am going to save the changes. Now you see that the username should not be null. Okay, we will set the username and then we will save it again. And that's it. You can see that now we have a user with an ID 2. Then I will go to the URLs. Then I am going to insert a new row. I will set the URL as test. It's just for testing purposes for now. Then the user ID, as we mentioned earlier, it was 2. Then I'm going to save that. And as you can see, we have an auto-generated ID for our URL. We can test it again. Let's leave it as test2 for the same user and save the changes. And as you can see, we got a new ID for our URL. So our method is working fine and everything is good till now. So we have created the migration and executed it, and we have a random ID for our URLs. And let's continue in the next video. After we have finished our migrations and we have tested our database schema and created a couple of rows in the database, now we have to test our next connection with the database. We have to try to get the data with Knex and see the whole Knex interface and how we are going to deal with Knex programmatically. So to do that, I'm going to create a main function, which is an async function in the index.ts, and I am going to test a couple of things in this main function. Now, first of all, I am going to move this function because it's an async function. I can easily make an await for this function in my main function. Then I am going to call my main function in here because most of you, I think, knows that we can't use the keyword await in the global scope. It has to be inside an async function. So that's why we have to create this function. So in here we will wrap this this section with try and catch. So, and we will catch any exception that will rise and we will print it. Then if we passed this line, that means that our database connection is valid and we can print our same old statement, database is connected. Now let's test our implementation. So source/index.ts. As you can see now, we have the same result, which our database is connected. Now, to use Knex in our application, we can use Knex in here. So database is ready. So we will import the Knex instance. We can import it in here because as you can remember, in the Knex file, we exported Knex as a default export, while we exported the function as a constant export. That's why we imported the function in a curly braces or curly brackets, and the Knex function or the Knex instance, we imported it as a default import. So now we can easily write Knex. Then in here we can specify the table name, which is in our case it's users. Then let's print the results of this query. So we can define users to be await for the next users, and let's log the results. Now let's try again, and as you can see, we can now see the user that we created earlier from the PG admin, if you remember. The ID is 2, username is test, password is test, and we have created and updated that. Now let's try a different approach, and let's set a condition where ID equals 2. Now we will run our query again, or our application again, and we will see that we will have the same results basically, but the query is different. Now I can set a parameter in my env variable or in my env file to see the queries that Knex is actually executing. So to do that, we are going to define a an additional environment variable called debug equals Knex query. This will print every query that Knex is executing to the terminal. So if we run our application again, you will find that first of all we are running our on database connect function, and then we are running the query select all from users where ID equals to 1. So, but the problem is we have to restart our application every time we are making some changes. So to solve this problem, we are going to install a package called NodeDaemon, which is a dev package in our situation. So we are going to install it, I'm sorry, not with the -g, but with the -d, because it's a dev dependency. We are going to install it, and then in the package.json file, we are going to declare a new script. So in here, I'm going to define a new script called start, which will be NodeMon or NodeDaemon, depends on how you want to say it, and then start/index.ts. So instead of executing the following command, so if we executed the following command, it's not recognized because, as I told you earlier, we haven't installed it as a global dependency. So we can install it as well as a global dependency. So if we executed the same command again, you will see that it's running actually, and it will actually give us the results that we need. And if we changed anything, let's say we want only to select the username. So as you can see, our application is restarting automatically, and now we have an array with an object that includes username in it. But we don't have to memorize this command every time. So we defined this command in the package.json, and we gave it a name, which is start. Now we can easily run npm run start, and npm will automatically search for a script called start and run it, which will eventually run this long command. This is very helpful, especially for long commands. You might see this command as a very easy command, and it's very easy to memorize it. But it's a common practice that all of the projects that you will enter, it's sufficient to run npm run start for the application to start, no matter what the package was, because I am using NodeDaemon. Someone else is using another library, so I don't have to know what this person is actually using in his application. It's enough to run npm run start and the application should start. So it's a common practice in here. So now I will close everything, and back to our main subject of this video is we are testing Knex interface. So let's say I want to, rather than getting the users, I want to get one user only, because as you can see now, I'm getting an array. So I will call the first function and then save again. And as you can see now, I'm receiving an object instead of receiving an array of objects. This is very helpful. Now, I want to insert a user rather than getting the users. So we will specify a username, which is, we will make it as test2, and we will specify a password as test as well. Actually, this query will not return anything because the insert function in itself will not return anything. But we can specify a second parameter for the insert that we will tell the insert statement to return the result to return the row that was inserted to the database. So now when we save, you will find that Knex is executing insert into users, and it's passing the username, the password and the username with the values and returning all. And we can see the results that we have a third user in the database with the ID 3, with a username and with a password as well. Now let's do the same thing for the URLs and insert a new URL to the database. we have to specify only the URL, which let's set it to Google, for example. And we will have to specify the user ID, which is 2. Or let's leave it as 3, the last one. And we will change it to URLs, and we will change it in here as well. And let's wait for the results. As you can see, we have a random ID that was generated. We have the URL, and everything works perfectly. So we have tested the Knex interface, and we have learned how to deal with it. We can, of course, remove. So let's say I want to remove this URL. I will copy the ID of the URL, and let's go to here and set a where condition where the ID is equals to this ID, and then delete. Then I want to get a list of URLs. So we will do it again, URLs, and that's it. So let's print, or let's start our application. So you will see delete statement, and then a select statement, and we have 2 results. I mean, everything seems fine, but the problem is we are using TypeScript, and we are not getting any autocomplete. So if I pressed on the autocomplete, I'm not getting the fields that are actually in the URLs. When I'm pressing the autocomplete in here, I'm not getting the tables that I have in the database. So you find like I'm using TypeScript, but at the same time, I don't have a type check on my database connections. So in the next tutorial, we will learn how to add a typing system to our Knex implementation. That will help us to avoid mistakes and to make our coding much easier, and will make us avoid mistakes in the future. So see you in the next video. So in our previous video, we tested the Knex interface, and we tried to insert some objects to the database, and we tried to make some fetch operations. The problem was that we don't have any autocomplete with Knex. Although we are using TypeScript, but TypeScript have no idea how is our database schema. We only defined our database schema in our migration file, but we can actually create another migration file and change our database and so on. So there is actually no way of knowing what is our current database schema that TypeScript should give us an autocomplete about. To solve this problem, Knex have an integration with TypeScript. So we can create TypeScript interfaces and inject them into Knex. To do that, inside the source folder, we will create another folder called types. This types folder should hold all of the interfaces, classes, types that we will create through our application. To make things simple for now, I will create an index.ts file, and I will keep everything in this file. I'm seeing that my application is actually refreshing with each, rerunning with each update. So I am going to stop my application and clear my terminal. Now, I will start by writing the interface for my user object, or for my user table, I'm sorry. So we are going to export an interface, which is the user interface. In the user, we actually have an ID, which is a number. We have a username, which is a string. We have a password, which is also a string. We have created at, which is a date, the timestamps that we created, and we have updated at, which is also a date. The second interface that we should add is the URL interface. So we are going to create another interface, which is the URL interface. And the URL also have an ID, but this time it's a string. It will contain a URL, which is also a string. The user ID, which is a number. Created at, which is a date. And the updated at, which is also a date. The final interface that we have to to create is the visit. The visit will have an ID, which is a number, URL ID, which is a string, IP, which is a string, and created at and updated at. So those interfaces actually match the database schema that we created in here. Now, how can we tell Knex that those interfaces are actually belongs to a tables in our database? We will declare a new module inside Knex/types/tables. So we are telling Knex that I am going to declare the tables that are in the database. Inside this module, I have an interface called table. It's called tables. And inside this interface, I have the key should be the name of the table and the type should be the interface that we created. This seems confusing, but it's actually simple. So what's the name of the users table? It's users. So I am going to write users and the type is user. The URLs tables called URLs and the type is URL. The visits table called visits and the type is a visit. And that's it. Now we have defined our tables and inject them into Knex types. Now we will go to the same examples that we were experimenting with, and I will try to get all of the users in my database. So I'm going to define users يساوي or equals Knex, and then I will open the single quotes or single quotations, and I will find that I have a list of the available tables in my database, which is URLs, users, and tables. Let's say now I will get a list of users. Then I will I will finish my statement, and then after that, I can check the type of the users. So as you can see, the type of the users is an array of users. So actually I can do something like console.log users 0 dot, and I will have the full attributes of the user. So I can actually just print the password of the first one. Let's try this. npm run start. And we can see easily that we have test as an output, which is the password for the first one. What's even better is that even in the where condition, I have autocomplete. So when I open the single quotations in here, I have an autocomplete for all of the attributes for the user. So I can specify, for example, an ID to be 2. So let's say I forgot that the ID for the user is a number and I put it as a string. In here, you will find that TypeScript will actually give you an exception because the ID is actually a number and not a string. So we will set it as a string and we will try again. We will have the same results, of course. So it even applies to the insert. So in the insert statement, I can open the autocomplete and I can see that I have the created at ID password. So I can set them safely in my application. So as you can see, the ID is a maybe a row column and the value of it is a number. So I can't do something like that because the ID is a number and string is not assignable to a number. So I can only do something like that. But as you can see, as I told you before, the insert statement by default will not return a value. So actually this statement becomes invalid and TypeScript will take it to our attention. So to make this statement valid, we can do something like that. So we are telling the insert statement to return this object that it was trying to insert, and now we have the error gone in this statement. Actually, we have an exception in here because the ID, we have a null in our username and we try to insert with an ID only. So as you saw in here, this even applies, for example, for the URLs. So I can do something like urls.insert, and I can see the autocomplete as well. So as you can see in here, we integrated TypeScript into Knex, and we injected our types into Knex so that we can write our TypeScript code safely without running into errors. This will increase our productivity while writing the code because we don't have to go to our migrations every time and check our code or our columns, and it will also minimize the errors that we will run into during our development. So by the end of this video, we have finished our model layer in the MVC structure. So actually the model layer is declared by our migration folder, which we specified our database schema in it, and also by our types folder, which we specified our types interfaces in it. And the integration between the two of them created our first layer, which is the model layer. In the next video, we will start by the controller layer, or we can call it the service layer. So we can start actually writing the logic into our application. So stay tuned. So in our last video, we have finished our model layer in our application. Our model layer consists of the migration that will create our users table, which contains an ID, username, and a password. It will also create for us the URLs table, which will contain the ID column, and also the function that will generate a random ID for each column for us, and the URL. And each URL will belong to a user ID. And we will also register the timestamps for each URL that we are going to create. Additionally, we are going to register the visits for each URL through our visits table by registering the IP and linking each visit to its URL. So also, we have finished our next configuration file by creating our next instance and linking that to our environment variables file. We have also finished our next CLI configurations, and we linked them to the same exact environment variable that we are using in here. Also, we added the support for TypeScript. We injected the dependencies from TypeScript into Knex so we can have autocomplete in our next instance. Now in this video, we will start by our controller layer or our service layer. This layer will hold all of the logic and business logic for our application. So we will start this layer by creating a new folder, which we will call it services. This folder will hold all of the required functions that will be requested from our application. We usually create a file for each entity that we have. So we will create a file for the users. We will create a file for the URLs. We will create a file for the visits, and so on. So we will start by creating a new file, which is the urls.ts file, which will hold all of our URLs related actions. So we will start by creating a new function, which we will call create short URL. This function is responsible of creating a short URL in our application, and it's an asynchronous function. The first parameter for this function is the body that the user will provide for us. The body consists of two things. First of all, the URL, which is a string, and the ID, which is an optional string. We referred to the ID as optional by providing this question mark after the name. So we can know that the URL, as you can see, the type of the URL is string, but the type of the ID is string or undefined, because we can actually pass the ID as undefined. The next parameter that we want is the user ID. The reason that we are splitting the user ID and not including the user ID inside the body is that the user won't actually provide his user ID to us. We will authenticate each user, and from the token that he will provide for us, we will know who is this user. So we are separating the body that the user will provide for us from the user ID that we are going to validate through our API's authentication process. Then we will continue with our function. To validate, first of all, we have to make sure that the user really did provide the URL. So you have to understand something. Let's try to call this function from TypeScript and not providing anything to it. As you can see, we will receive an exception that this function expected 2 arguments but only get 0. We can provide the first parameter as an empty object and a second parameter as null. And we will still get an exception because this function actually required the URL to work. Although we can't bypass the TypeScript validations from our code, the user, when he sends the request to us, we can't validate it through TypeScript. And as I told you before, we will compile our TypeScript code into JavaScript. So TypeScript will only help us through our development, and it won't do anything in the runtime when we deploy our application to the production server. So we have to do our validation manually by checking each parameter if it exists or not. So if the request don't have a URL, so we usually we use this operation to check whether the variable exists in TypeScript or not. Of course, the URL is inside the body, so we have to check if we don't have a URL inside the body. So there is a very bad practice that I see that usually people will return something like false, for example, which indicates a problem. This is a very bad practice, first of all, because you can't know why this function is returning a false to you unless you read the entire function, which is not very efficient and it's time consuming for other developers. The second bad practice that I see, which is better than the first one, but it will also remain as bad practice, is to return an object. Let's say we will return isError, which is equals to true, and the message is URL is required. While this way is better than the first one, which is we will return only false, but it's also not very standard because you can, for example, we are going to build an API in front of our service layer. So we can't possibly know the status code of this error. We will discuss the status codes later in our course, but we have to know that this is not the optimal way of returning an error to the caller of this function. We have to use the standard way that the programming language provided to us, and we will do that by actually throwing an exception. Throwing exceptions is the standard way that the programming language uses to indicate that there is a problem while executing this function. So we can actually do something like throw new error, and we will provide the error message, which is URL is required. Then if we have an ID in our body, we can insert the record into the database by going into Knex, which we will import from config/Knex. And then we will provide the table name, which is URLs. Then we will insert a new record. And in this record, we are going to provide the URL and the ID that the user provided to us. The URL, which is the body.url, and the ID, which is the body.id. Then we have to provide something else, which is the user ID, which we have already in our function. Then we are going to return the full object that we are going to create to return it to the user and store it in a variable, let's call it results. The problem in this function is that we did not validate whether the user is passing an ID for us or not. The ID is optional. We can give the option to the user to provide an ID, or we can create an automatically generated ID for him. But if the user provided an ID, we should check whether the ID exists in our database or not. Because if the ID exists, we should provide the user from continuing and going into the next step. So we will check if the body contains an ID, where we should validate if we have any record that contains this ID. We can do that by executing the following. We will create a new variable called current record, and this current record will equals to Knex on the table URLs, where the ID equals to the ID body.id that we have. Then we only need the first results, because if we have one result is enough. We actually here won't get any more than one results because the ID is unique. So it's impossible to get more than one result. But it's a best practice to always include the first result to eliminate some extra work that your database have to do. Then we will check if we have a current record. That means that this ID exists in our database. So we will throw a new error and we will notify the user that the ID that you provided is or already exists in our database. Then, if everything went okay from here and the current record was undefined, we will go and create our new URL. The problem is in here, if we returned the results as is, the results actually is an array. Although we inserted one object to the database, but this return statement will actually return an array of inserted objects. So we have to return the results on the index 0, because we know that we only inserted one object, so we only need the first index from the results function, from the results array. The second function that we have to do is resolve URL. This function will actually resolve URL is actually an async function which will take an ID that the user will provide for us and will return the actual URL. So to do that, we are going to get the URL from the ID by executing the following statement. Await Knex on the table URLs, and then we will get where ID equals to the ID that we already have. Then we will select only the URL column from it, and we will get the first results. If someone is now confused because I'm doing like this, like I did in here, and sometimes I'm doing like this, is that because if I have the same exact variable declared in my function, I don't have to do this operation again. JavaScript will automatically search for a variable that have the same key and provide it to the object. So in here, I already have a variable called ID, so I don't have to mention the ID twice. JavaScript will automatically know that there is a variable called ID, take its value and put it in the object. Then in the second statement, I'm selecting the URL column only. If you remember, the URL table contains the URL, contains the ID, contains created at, contains updated at, but we don't need any of them. For this function, we only need the URL. We should not fetch any column that we don't need because it would create an extra overhead for our database. Then we have to check, maybe the ID that the user provided for us is invalid, so we don't have an URL with this ID. In this case, we will throw a new error and we will notify the user that the ID is not valid. Then, if everything went okay and we have a URL, we are going to return the URL.URL. This is because the URL is a variable that I declared, and the actual URL is a property inside this object. So in this video, we made two important functions. The first one is create short URL, and the second one is resolve URL, which is the core of our application if you think about it. In the next tutorial, we will continue and write a couple of important functions for our course, which we will write the update URL function, delete URL function, and get URLs for a single user. So let's continue in the next tutorial. So hello again. After we have finished our create short URL function and resolve URL function, we should give the user the ability to update his URL that he have created. We will do that by creating a new function, which we will call update URL. This is an async function, which will ask the user to provide multiple things. The first one would be the ID of the URL, which is a string. The second one is the body, which will contain the URL as a string. Sorry, we have to put the type in here. So the third one is the user ID for the user that is trying to update this record. Now, the first thing that we have to check in this function is whether that the URL really exists or not. So if not body.url, I'm sorry, if not body, why we don't have it? Okay, because we opened an array brackets in here and we need function brackets. So if not body.url, we will actually throw a new error for the user, and we will mention that ID or what we will mention in here. We will mention for him that there is really nothing to update. So if you don't have a URL, that means that what are you exactly updating? So we will tell him that the URL is required. Then we will try to get the URL itself. So we will do that as we did before by going to Knex, await, Knex on the URLs table. We are going to check where the ID equals the ID that we need, and we are going to get the first result. In here, what we actually need in the URL that we want to receive is two things. So we are going to specify what columns do we need actually from the URL. We actually need, for now, we just need the user ID. We don't need any other object or any other attribute. So we are going to check if the URL did not exist. We will throw a new error and we will tell him that the URL is not found. Then we are going to check a second thing, that we have to check that the URL, the user that created the URL, is the same as the user that is trying to update it. So we will check if URL.userid, if it was not equals to the user ID that is trying to update, we should throw a new error, and we should provide that you don't have permissions to update this URL. Now, what's left for us to do is to get the results of the update operation that we are going to do, and we will do the update operation by going to Knex, to the URLs table, where ID equals to the ID that the user provided for us. And then we are going to update the URL with the URL that we already have. We are getting an exception in here because we don't have a URL. we have something that we call body.url. See the problem in here, we have a URL as a string variable inside the body, and we defined a variable called URL. So when I tried to update it like that, and to benefit from JavaScript allowing me to have this shorthand, this is where the beauty of the types that we created for TypeScript will come. Here it's telling me that type URL is not assignable to type string because it's actually taking the URL variable that we created and not the URL that is inside the body. So we have to specify that we need the body and the URL that is inside the body. The second parameter that we have to provide for the update function is the returning parameter, which will tell Knex to return the object that you updated in the database. Then, as the insert statement, the update statement will return an array, so we have to return results and the index 0. The last function that we have to do in this service, or the last function related to the URL, is the delete URL function, which is first of all an async function that will take the URL ID and will take a user ID as well. First of all, we have to get the URL that the user provided for us. So as we did earlier, we can actually copy this one and paste it in here. So we can check the ID or we can check the URL that we are getting. Then the same exception that we throw in our update function, we will throw it in here. We have to make sure that the user that is updating this URL is the same user that is trying to delete it. Then if everything went okay, we will make the delete operation basically. So we are going to go to Knex, to the URLs, and then where the ID equals the ID that the user provided for us, then we will execute the delete function. Please make sure that you execute this statement with the await keyword, because the way that Knex operates, if you did not mention this await function, Knex will assume that you want to do something else to your query. So let's say you are going to do something like that, and we are going to call this query builder. If you can see, if we call the query builder again and check the parameter, we will still have the where condition, which is a query building operation. We will have the insert, we will have the delete, we will have all of those functions. But the moment that we include this await keyword, we will find out that this variable changed completely, and it will not have those query building criteria. So even though we don't need anything to return from this delete statement, it's very important to add this await function, because it will actually trigger the delete function to execute the query that we are trying to build. Then after we delete this URL, we will just return true to the user, and that's it. The final function that we are going to do is related to the user and related to the URL. And in this function, we are going to return all of the URLs for that user. To do that, we are going to do the following. We are going to declare a new function, and we will call it getURLs. This is an async function which will take basically a user ID, which is a number. In this function, we are going to do as we did before. We are going to define results, and this results belongs to await Knex on the URLs table. And we are going to get all of the URLs where the user ID, actually in here we made a typo, it's user ID, not user, where the user ID Why it's not working? The user ID equals to the user ID that we have in the function body. But here, those results might be huge. Like, for example, if we have an active user in our database or in our system, maybe this user have 1,000 URLs or 10,000 URLs. So it's not reasonable to give him all of his URLs, because that will create a huge overhead on our database. So we should ask the user to provide two more parameters, which we call pagination parameters. Those pagination parameters are usually the limit, which is a number, and the offset, which is also a number. Those pagination URLs are responsible of limiting the number of results that the user will get with each request. So to add that to our query, we will add another statement, which we will call it the limit. The limit will actually limit the number of numbers that the user is going to provide for us. The number of results that we are going to provide to the user. So usually this number is set to about 15 or maybe 20, 30, but nothing more. So if the user did not provide any limit for us, we will provide it as default as 15. Then let's say the user got his first 15 results and he wants to get the second 15 results. How can he do that? He will do that by passing the offset variable. This offset variable is usually set to 0. As you can, I made a typo in here, yeah. As you can see in here, I'm using the OR operator. So if the limit is not existing, or the user did not provide the limit, we will take the second value. Here, the same thing. If the user did not provide an offset, I will take the default value, which is a 0. We can also do it in another way by providing it as a default parameter in the function, like this. And it's also a valid way of doing that. We will keep it as simple as possible for now. So to demonstrate to you what the user will pass for us when he wants to get his URLs, we first have to retain the results, and then we will demonstrate this for you. So let's say he wants to get the first page, which will contain the items from 0 to 15. He can do that by requesting the getURLs function. He will pass his ID, it's 10, for example. He will pass the limit as 15 and the offset of 0. That means that we are starting from the index 0. So for the second page, because he got all of the results from 0 to 15, now he wants from 16 to 31. So he will do the same exact function, getURLs, at ID 10, and he wants the limit to be 15 as well, but he wants the offset to be 15 as well. So the function will start getting him value from actually 16, because we are offsetting the starting pointer to start from 16. We are offsetting it by 15 digits, which will make it start from 16. So it's a very simple pagination that we did in here that will clear some overhead on our system's shoulders, and it will make the system run much efficiently and much simpler. So in here, we finished our URL service. We created the function that will create a short URL. We created the function that will resolve an ID to a URL. We created a function that will update an URL. And we created the function that will delete a URL. And the final one that we did is to get all of the URLs for a specific user. So in the next video, we will start with the visits service. We have to actually track the visits for each URL that we have, so the user can know the traffic that is going through his URLs. So see you then. Hello everyone. In this tutorial, we will talk about validations. Although we have validated user input manually in our service functions, this is not the best way to validate the user input in general. The aim of this course is to teach you how to do things with best practices, not just teach you how to do things and that's it. So as you can see in here, we have validated if the user have provided the URL parameter or URL attribute for us or not, but we have done it manually. The next important thing that we haven't done yet is to validate that this is actually a URL. As you can see in here, it's just a string validation. So the user can easily pass an invalid URL to us and we will totally accept it. And this should not be the case in our system. We should validate the URLs. Although we can go to the internet and search for some regular expression that will validate the URL for us, we are aiming at something big. And when you have a body with 10, 20, 15, or maybe 50 attributes, you can't do the validations manually. And there is a huge number of validations to do. You validate if the string was minimum of those characters or maximum of that. You have to validate a URL, a number. There is so much validations that you have to do. So for that, we are going to use a custom library called Validator.js. To install this library, we are going to install it using npm. By installing it, npm install validator.js. After the installation finishes, we are going to go to our main function and comment this one because we don't want to connect to our database now. We just want to test the library. So we are going to import validator from validator.js. As you can see in here, we have to download the types for this library as well, because the types are not included in this library. So we will do that by actually installing the types as a def dependencies at types/validator.js. Now we will wait for npm to finish, and now we have the types for this function, so TypeScript can actually validate the code that we will write. So to use this library, it's actually pretty close to how Laravel do validations. If you don't know how library does it, I will explain in this tutorial. So to validate with validator.js, you will provide your validations schema as string, as following. So first of all, we are going to define a validation, which is equals to new validator, the validator that we imported from the library. This validator will take two parameters. The first one is the data that the user provided, and the second one is the rules or the schema. So we can do something, for example, if the user passed for us a URL, and let's say that the URL value is test. And in the validation schema, we told it that URL is actually a string, and we refer to the and with this operator, which is a single or symbol, and required. We can add more validators by concatenating them. For example, I needed a minimum of 5 characters and maximum of 15, and the list will go on. If you check the library documentation, you will find a very huge amount of validators that you can use out of the box. So for now, we are going to test that the URL is a string and required. So to know if our validator passed or not, we are going to use the following function, which is fails. So we are going to check if the validator fails, we are going to log validator fails. Otherwise, we are going to log console.log validator passed. So let's try it. We are going to start our application, and it's not actually yarn, I'm so used to it. It's npm start. Now, as you can see, validator passed, and that's because we provided the URL and it's a string. So now let's remove the URL from the input and try again. As you can see, we got validator fails. So it's actually pretty good. Let's try to swap the string and replace it with URL because they actually have the validator of a URL. And let's try it. So URL equals test, the same one. And let's try. Actually, now it's giving us validator fails because the URL is not actually a URL. It's a normal string. So how can we know the error message that we got? We can know it by logging the following object, which is validation.errors. So this object will actually give us a list of or an object with our validations. So if you check this one, we can get, for example, an error for a specific attribute. So let's get the errors, for example, for the URL, and let's see. As you can see in here, the errors for the URL are this one. The URL format is invalid because we specified in here that it's a URL and required, but it's not actually a URL. So now we have to get, let's try to get a full errors. I want to know all of the errors in my schema. So let's rerun again. So as you can see, the errors object is an object. The key is the key for the attribute itself, and the value is an array with errors. So pretty good till now. Let's try a couple more validators. So for example, in our case, we have both an ID, which is a string, but not required. So for the user, we either going to generate a random ID for him, or he can provide an ID himself. So to do that, the ID, we will not give it a required parameter, but we are going to give it some constraints. So it's a minimum of 5 characters and a maximum of 10 characters. And let's try. As you can see in here, we only have one error because the ID is not required. So let's try to enter the ID as 1 character only, and let's see. As you can see in here, now we have 2 errors. ID must be at least 5 characters and the URL format is invalid. So let's try to make a valid object. So we will start that by, let's add Google URL. And for the ID, I am going to add, let's say, this one. As you can see, validator passed. If I try to put more characters in here, I will have the same error. The ID may not be greater than 10 characters. So actually, this library can do exactly what we need. Now, I will explain in the next tutorial how we can utilize this validator function into our services and use it to validate our requests. So bear with me. So now that we have tested our validation library, we actually need this library to give us one string error. We don't need this complex object because we can't throw it. If you remember, error throwing will have a message, and the message will be a string. So how can I throw those errors that are provided by this array? So I can't do it, to be honest. So what we are going to do is that we are going to convert this object. So let me put the object for you. So let's create an error with this one, and let's create an error with this one. And let's run our application, npm start. And let's copy the object that, why it's not giving us, oh, okay. The URL is the ID is still valid. Okay, now, okay, it's valid. So let's take this object and put it in here so we can watch it and keep our eye on it. Now, let's call it X, just to remove this error. Now we have to convert this object that we call X, which is the errors, into a string. We are going to go over the attributes of this object. So to do that, let's keep those as an object, and we are going to call it errors, which this errors object is basically the same value as this X object. I just placed the X object in here so we can have our eyes on it all the time. So it's easier for us. And let's try and get the keys for this object. So to do that, we are going to use the function object.keys errors. So let's try and print this one to see the value. We will hit enter. As you can see, this array will have ID and URL, which is the attributes that we have a problem with. So it's good. Now I am going to use the function for each, and for each key that I have to do something. So what I'm going to do is that I am going to introduce a new, let's call it aggregated errors. And it's an empty array. Actually, we'll define its type, which is a string array. Now we have to go through this object or this object and add this one to the aggregated errors. So we can have all of our objects at the same level. So now to access this one, so we are going to do the following. We have the key, which is either an ID or URL in our case. We are going to go to our validation object into the errors, and we are going to take the first error for this key, which is in our case will be, for example, the ID must be at least 5 characters. Let's try now our code and actually printing this value to the console so we can see what we are dealing with. So as you can see, the first time we got the ID must be at least 5 characters, and the second time we got the URL format is invalid. So simply, we are going to take this value, remove this console log, and go to the aggregated errors and push this error message to it. We have now an error message that the argument string or false is not assignable to type string. So we are actually going to cast this value to string, and that's it. Because actually this array, if for example we don't have an error with URL and we passed the key as URL as following, it will return false for us. So it will not work with TypeScript. But we know for sure, because we are going through the errors, that this key exists in the arrays object. Now, after we added all of our errors to the aggregated errors array, we are going to log it to see how is our aggregated error right now. Let's call it errors. Actually, it's not error, it's aggregated errors. So as you can see, we have an array with 2 items. The first one is the ID must be at least 5 characters, and the second one is the URL format is invalid. Now we are going simply now to use a function called join, which will convert this array into one string. So let's see how the join function works. As you can see in here, now we have the first error, then comma, which is the join key, then the second error message. That's it. So perfect. Now we have a single error message that we can use. So if the validator fails, we will throw a new error and we will simply put this string to the error. So now let's try it. As you can see, we have a big error that we actually generated that is telling us that the ID must be at least 5 characters, the URL format is invalid. So perfect. That's exactly what we need. Now this logic, actually this one we don't need anymore because now we know how to transform the object. But you see this logic, we have to do this logic in each function. So we have to do it in the create short URL function, we have to do it in the update URL function, and it's a very hideous thing to do, and it's very wrong to do that as well. So I am going to create a new service. I am going to call it validations.ts. In the validations.ts, I am going at first to create a function to create a short URL. So I'm going to export a function. Let's call it validate create short URL. This function will take the body, which is actually a generic type or a generic object. The key would be a string and the value would be anything. So we can demonstrate this with TypeScript by annotating the following. It's an object. The key for it is string. Then the value for it is any. And that's it. Now we are going to move all of this logic to that function. Let's stop our application to not run it, and we are going to uncomment our main function. Now I moved it. We forgot to move our import as well, so we are going to move our import to here, and that's it. Now it's running perfectly. Now instead of passing this mock body, we are going to pass the body that we actually got from the function. And we have the validation schema. But here we have the same problem because I am going to create a new validation for validate update short URL, which will have URL to keep consistency, which will have the same exact body, and then I am going to repeat the same process. So to solve this problem, actually we are going to validate all of the objects the same. The only thing that would change is actually the body. So in the next tutorial, I will show you how I will composite all of those into a single function, which would be our last part about validation. So bear with me to the last part. Thank you. So now the only thing that is left for us is to move our validate common logic into a separate function, and we do separate for each different object or for each different schema, we are going to deal with it differently. So to do that, I am going to create a new function. Let's call it validate body. This body, actually before I do that, have you noticed that I am using this interface multiple times in my application? So I can actually declare it, so I don't reuse it each time I have to rewrite it. So I can define a type, let's call it request body. And this type is actually an object. The key for it is string and the value is any. Now I can easily replace all of this with request body, as you can see. See, it's a little change, but it will make our code much cleaner. And now if I have to change my request body, I have to change that one. So now my third function, which is validate body, will also take a body. It's not an async. Why did I put this one as an async? It's a normal function actually. So my validate body function is actually a function that will take a body, which is a type of request body as well. And that's it. It will take the validation body and it will take another thing, which is the validation schema itself. We can actually get the type of the validation schema by using this validator that we imported. There is an interface called rules. This way, our validation schema, if we check the type of it, is the same that we are creating in here. So we will have autocomplete. So we are going to move this entire logic into our validate body object, basically. And then this one, we are going to replace it with our validation schema that the user already passed for us. So as you can see in here, we have a validate body function that will take a body and a validation schema, will create the validation, check if it fails, get the errors, handle them, convert them into one string, and throw them. And otherwise, it will return true. That's it. Now, what would we need to do in this validate create short URL function? Basically, this function will only call our validate body function and pass the body for it, and we are going to write our validation schema. So for our validate create short URL, we have a URL, which is a URL and required, and our ID is actually a string with a minimum of 5 characters and maximum of 10 characters. That's it. Now, our update function is actually just a URL. So the URL is required, but the ID, we are not going to pass it at all because we are not going to validate URLs in the update. As you can see in here, if we went to our URLs service and went to our update URL, there is no ID in here. So we are only concerned about the URL. So now our validation functions are ready. We can actually use them. So now this is the create URL or short URL function. We are going to remove this and replace it with validate create short URL. And we are going only to pass the body for it. So now if we have any problem with our body, the validate create short URL function will actually throw an exception for us. And it will prevent the code from continuing. So if we actually reached in here, that means that our body is totally valid. Now we are going to do the same with our update URL by validate update short URL and passing the body as well. This method of validation will become very handy in the future, and it's the best practice of validating your objects. So now you don't have to make any validations or any extra validations yourself. As you can see, we have validated the URL, required, string, minimum, and maximum with zero effort. I can actually go to the browser and search for validator.js npm and find my library, which is this one. I can go through the different validations that they have in the docs. As you can see, they have a huge number of rules. Something for date, for arrays, they have for booleans, they have digits, they have email, hex, even in, which will check if the value is in a specific array. So for example, let's say you have a gender. So you have, it's a string and required, and it should be in male, comma, female. So it's totally doable with this function as well. We have something like maximum, minimum, we already used. Not in, numeric, present, required if, which is very important. Required if is a very useful one, attribute that I use. Required unless, required with all. As you can see, there is a huge number of rules that you can use in this function or in this library, which will make your life easier. And with the little function that we created, we made our life much easier. We made our code consistent and clean. As you can see in here, we are only calling a small function, and this function is only passing its schema. And the whole logic is happening in here. So if we want to change our logic, we will change it once. So we will keep consistency in our application. So now we have finished the errors. We have finished the validations. The errors actually will cover in the next tutorial. Because as you can see in here, the way that I am throwing errors is a little bit confusing. Because when I'm throwing an error, you can't actually know what is this error telling us. Is this error telling me that there is a resource is not found? Is it forbidden? Is it a bad request? Is it a conflict in your database? What is the status code of your error? So in the next tutorial, we will cover the HTTP errors throwing and how we can optimize it. So see you then. Hello everyone. So now we have covered the validation aspect of our application. But as you can see in here, we are throwing exceptions as raw errors. There is nothing that would tell us what are the content of this errors, or what is the subject of this error, or what is the aim of this error. Also, our error is so generic, we can't actually know whether we actually produced this error or it's actually a serious error that we should solve. So for example, when our application throws this error, which we already know that our application will throw, we should not panic. But when our application throws another exception, so let me demonstrate for you. I will comment this one, and let's have this variable, which we will call x. Will set the value as any, and its value is null. And let's say x dot includes 10. And that's it. Let's execute our program. npm start, not npm run. Okay. So as you can see in here, we have an exception, which is telling us, where is the exception? It's telling us somewhere in this long exception that we actually called a function that does not exist. So there is a problem that we have to solve immediately because this exception was not planned. But this exception, we should not worry about it because it's a very simple exception, because the user, for example, in here provided an ID that we already have. So we should not panic about it. So we should differentiate between them. We should be able to know what exception that we actually produced and what exception is actually coming from the system, and we should immediately solve. Because in the big applications, we have some softwares that will log those exceptions for you. So when there is any unexpected exceptions in your application, you should get notified and you should solve it immediately. So we will solve it a problem by problem. So the first problem with our method of throwing this error is that we don't know the subject of the error and we don't know what is this error about actually. So to do that, because we are developing an web application, we can use the HTTP status codes. The HTTP status codes are a set of codes that are well known in the entire industry. Each code, what does it mean? So for example, when you request something from the server and the server returns 400 to you, that means that this is a bad request. When you request something and it will return for you 404, it means that not found. Actually, you have to read the message to know what's exactly they did not found, but you have a clear perspective that there is a not found error in here. You have a more popular one, which is conflict. We will use it in case the ID already exists in our database. We have something called OK, which we will return by default if nothing wrong went with the application. There is this one, which is internal server error. This is a very useful one when we have an exception that we did not plan it, as I told you before. So to use those status code, we are going to use a library that will provide them for us. So let's install it. So we are going to clear the terminal. We are going to install the package npm install http errors. This library is actually very lightweight library. It will only provide for us a set of helper functions that we can use in our application. So we are going to import it, and we have the same error that we need to add the types for this library. So I copied the install and I am going to execute it in here. That's it. Now the error should be gone, and it's gone. Now in this function, in here I encountered that the record, the ID already exists in our database. So how can I actually use this library? So I will keep my throw, and I will actually going to copy this one to my clipboard. this error message, and I'm going to delete those. So to use this library, we are going to make a new HTTP error, and when we hit on the dot and see the autocomplete, you will find all of the HTTP errors that we've seen before defined in it. You have the option of either throwing it as a number, which is, I find, not very readable. I mean, you will get used to them by time, but I find the second way is way more readable, which is to throw it as the exception name. So actually, this is a conflict error because they provided an ID and we already have this ID. So it's a conflict. So if we hit enter, you will see that it's asking you for the message. And as you can see, it's an HTTP error with a code 409, which is a conflict error. So now I can paste the error message that I already copied. And as you can see in here, now I know that this exception, when I see it in the terminal, this exception, I already know that my application will throw. So I can safely ignore it. I don't have to log it. I don't have to panic. And I don't have to do anything about it. The user just have to change the ID and that's it. And here, for example, we don't have a URL. So the user provided an ID, but we don't have this ID in our database. So let's throw a new HTTP error, and it's actually not found. Okay, perfect. It's actually an HTTP error with 404, and the message would be URL not found. Now, in the next function, we have the update function. We have to throw multiple errors in here, actually. We have to throw, first one is URL not found. I'm going to copy it as it is from the upper function and keep it in here. The second one is about permissions. So I'm going to cut this error message, remove the generic error, and throw an unauthorized error, which is 401. And I'm going to give the same error message. Now, in my delete function, I actually have the same exact two exceptions that I have to throw. So I am going to go in here and replace them. The only thing that we have to change is our validations library. In here, we are throwing the error as a generic error, but we have to throw it as we learned now. So I'm going to import HTTP error from HTTP errors, and then I am going to throw a bad request, because when the user provides a missing body, it's actually a bad request. So HTTP error.bad request. So why is this very useful? So actually this is very useful because inside the HTTP error, I have a function that is called isHTTP_error. So let's see it. I will import it in here to test it out from HTTP errors. And as you can see in here, isHTTP error. So let's try a scenario. In here, I am going to call let's create a short URL. The body for this URL, I am going to provide an invalid URL. And I'm not going to provide an ID. And for the number, I'm going to provide ID 3. I think we have it in our database. And I am going to await for it. And let's print the exception that we have. And let's start our application. No, I keep doing this. It's npm run start, not yarn. Yarn is another package manager for npm. I was planning to use it, and I use it regularly, but I did not want to make the course so confusing, so I stick with the normal one, which is npm. As you can see in here, the exception is formatted, but when I'm doing this to the terminal, it's actually clearing some of the exception. So let's execute it again. There is something weird happen with the terminal when you minimize it. So as you can see in here, we have a bad request error. The URL format is invalid, which is a very clear error message. So now let's try and let's say we are going to change the port of our database. Okay. This will require an update, an app reload, because environment variables won't be detected. And as you can see, I received another error. Connect something, and the port is invalid. How can I differentiate between them? So I will go in here and I will type if HTTP error dot is HTTP error. That means that if this exception is actually an HTTP error that I throw, I will log ignore this error because I don't care about it. Else, this is serious, and I will log the exception. So now let's get our port correct. Let's restart our application and let's see. As you can see in here, it actually told me to ignore this error because this error is an HTTP error. This one is because my database is connected, as you can see. I actually reached the exception of the URL is not valid. So it's actually telling me to ignore this error. I will print the error to make it clearer. Let's see. So as you can see, ignore this error. It's a bad request. The URL format is invalid. The last thing, I will go and change my database port, which is a very serious exception. As you can see, this is serious and printed the errors for me. So I can really differentiate. I can in here send the error to the logger, so the logger can notify me and tell me there is something serious with your application. But in here, I don't have to do that because it's a planned exception. Or here we tell operational exception, and here we call it non-operational exception. So in this tutorial, I am going first to clear the mess that we created in here. So let's clear it. I'm going to log the error in here only. I'm going to remove the function call. And that's it. So in this tutorial, we learned about the exceptions and how we can throw them the correct way. We replaced our error throwing by the correct HTTP code. So this one, we have it as an HTTP code 401, which is unauthorized. Here we have unauthorized, not found, and so on. This is a very good best practice to get used to, and it will make your application much more organized and much more efficient. And you will easily be able to log the important exceptions only, and you don't have to panic on each and every silly exception that is already planned in your application. In the next tutorial, we will continue with the fun stuff. We will create the visits service, and in the tutorial after that, we are going to start with the users service. So see you then. Hello again. So now that we have finished exceptions throwing in the correct way, and we finished our validations as well, now we can move and continue with our services. So the next service that we have to do is the visits service. So we have to track each URL who visited it, so that we can keep track of all of the URLs or the most URLs that have traffic, and the user should be able to know how many visits he have got to each URL. So to do that, we will start by importing Knex from our configuration, which is config/Knex, and we will create the first function, which is register visit. This function is an async function that will take two things: the URL ID, which is a string, and the IP of the person who visited the website, so which is a string also. This is actually don't need any validations and don't need anything, because this function will get called internally. So our system will call it. The user will not call this function. So this function, let me explain something to you. In JavaScript, it's a JavaScript tip. So in JavaScript, when you have a function that executes one line only, you don't have to open the curly brackets. You only add the line. So for example, if I have a function that will print hi, I don't have to do it like that. I can easily do it like that, because it's a one-line function. So I can easily do that with JavaScript. So I'm going to utilize this. This function will only insert to the visits the following. Dot insert. We are going to URL ID will be the same and IP will be the same. And that's it. We don't need anything more. So we are going to use this register visits in our URLs service by going to the resolve URL function. So after we made sure that the ID that the user provided for us is valid and we reached here, we have to register the visit. And to register the visit, we are going to pass the URL ID, which is called ID in here, and the IP. So the IP, we have to pass it to this function. So anyone that will call this function should provide an IP. So now, every time we are calling this resolve function to get a URL, we are registering this visit. Now, we have to tweak a function that we already wrote in this service, which is the get URLs. So basically, when you give a list of URLs to the user, you should tell him each URL how many visits he have. So I should be able to know at a glance that this URL have that many visits and this URL have this many visits and so on. So in this line, I am going into the URLs tables, and I am getting the tables, the URLs under this user ID. So I can easily join or left join the URLs tables with the visits tables. And I can join them on urls.id equals the visits.url ID. If you know SQL, this should be very familiar to you. It's equivalent to select all from URLs, left join visits on visits.urlid equals urls.id. So it's actually equivalent. Now we are going to select a couple of fields that we should get. So we are going to select the urls.id to get the URL ID. We are going to select urls.url to get the actual URL. And when we created this URL, so urls.created, created at. Then the final thing that we should select is actually the number of visits for this URL. So remember when I told you that each time we have to use a row query, we have to add it into a row function. So I have now to use a row query. So next.row, then I have to count the visits. So I will use the function count visits.id. And I will call it visits count. Again, if you know SQL, this should be pretty straightforward to you. So because we are using the count function on the visits, we can't actually use it unless we grouped by this one. So in here, I have to add group by, and then I have to group by the urls.id. So why did I group by the user's URL's ID? Because the way that the results will be visible to us is that each URL will exist in the database multiple times, because each URL will be associated with its visit. So when I group by the urls.id or the URL ID, I will have each URL as a single line. And after that, I will count the visits for this URL ID. The final thing that I should do is to order by the visits dot, or we will order by the URLs dot created at, and I am going to do it decrementally, and that's it. So this function, to repeat, will select from the URLs tables where the user ID equals the user ID who created this URL. Then we will left join with the visits table on urls.id equals visits.id. Then we are going to select urls.id, which is the URL ID, the actual URL, and the created at. And then, because we want the number of visits for each ID, we have to use the function count, which is a group by function. So we are going to count the visits.id, and then we are going to group them by the ID. So each line will represent one URL only, and this column will contain the number of visits for this URL. And finally, I am going to order them by the created at. So there is two functions that I need to add to the visits URL, to the visits service, and that's it. The next function, I should get the last visits for a user. So user ID, and remember when I told you that we should not pass huge amount of data to the user, in here we should pass also the limit and offset. So what this function will actually do is, let's say I have 10 URLs and I'm sitting on my dashboard, going into the dashboard. I want to see at this moment what URLs are getting visits. So this function will give me the visits that any of my URLs are getting, regardless of the URL ID. So to do that, it's actually the same. We are going to go to the visits table in here. And then from this visits table, I'm going to join it with the URLs. So in the previous example, we selected from URL because we actually want URLs, and then we join it with the visits. Now we need visits. So we will select from visits, then join it with the URLs. Because in the visits table, if you think about it, and we go to the visits, in the visits, I don't have user ID. I have URL ID. And each URL will have a user ID. So I have to join the visit with the URL so I can know the user ID for this URL. So I'm going to join on urls.id equals visits.urlid. Then I'm going to select urls.id, urls.url, visits.ip, and visits.created@. So as you can see in here, selected from visits, join it to the URLs, and then I selected the URL ID and the actual URL, the IP for the visit, and when did this visit happen. Then I am going to add a where condition where the user ID equals the user ID that we know in here. Then, as we did earlier, we are going to add the limit, which is a limit or 15. Are going to add the offset, which is an offset or 0. Then the final one are going to add order by. We are going to add order by visits dot created at descending. Notice in here we have to specify created at from which table, because we have if we went to the database, we have a created at in the URLs and we have a created at in the visits. So it's ambiguity. We have to specify I need the created at for the visit, because I have to see for example, the newest 15 visits, not the newest 15 URLs that I created. Okay. So now the final one, really the final one, and we will be finished by the visits, is I should be able to get visits by URL. So it's an async function. I will pass the URL ID, which is a string. And also I will pass the user ID, which is a number. I should pass limit, which is a number, and offset, which is a number. This function will get the visits for the URL, but only for if the user owns the URL. We are not going to provide the URL for anyone, the URL visits for anyone. Only if you created the URL, you can know who visited this URL. So first of all, we have to check that the URL exists. So I'm going to get the URL, await next on the URLs where the ID equals the URL ID. And I am going to select, or actually here it's URL ID, and I am going to select only the user ID. I don't care about anything else. And I am going to get the first result. Then, if the URL did not exist, then I should throw a new HTTP error. So I have to import it. Here I will import HTTP error from HTTP errors. And what we say about if we did not find the URL, it's actually URL, not URLs. I will throw a new HTTP error, which is not found. And I will specify URL not found. Then we will check if URL.userid was not equals to the user ID that is actually trying to get the URL visits. We are going to throw a new HTTP error, which is unauthorized. You don't have permissions to view this URL. Then if everything is okay, we simply going to the visits table, and where the URL ID equals the URL ID that we have in here, we are going to limit that for limit or 15, and offset is offset or 0. Then the final thing, we are going to order by created at descending. Notice in here, we did not have to specify from which table as we did earlier, because there is no join. There is only one created at, so there is no ambiguity. So as you can see, we created a function to register a visit. We got the last visits for a user, and we got the last visits for a URL. And additionally, in the getURLs function, we added the count or the number of visits for each URL. So in the next tutorial, we will learn about authentication, how we are going to register new users, authenticate them, and more. See you then. So now, after we have finished our visits service, we have to start with our users service. So our users service is actually simpler than other functions that we already did. So we have two main functions. The first one is the register, which is an async function that the body will contain a username, which is a string, and a password, which is also a string. And we have another function, which is the login, which will have the exact same body, which is the login that will take a body that contains a username, which is a string, and a password, which is also a string. Now, to start with the register function, we actually have to check two things. We have to check that the username and password exists already in the body, and that the passwords will meet certain criteria. So we are going to go to our validation service, and we are going to define our register validate register, which will take a body, which is a request body that we defined. And this one will validate a body, will pass the body to it. And the schema in here is pretty simple. The username should be a string, required, and also minimum of 4 characters and maximum of 8 characters. The password should be also a string and also required, minimum of 6 characters, and we are not going to make any maximum for the password. The user can input any password that he wants. So we are going to go to our register function and validate register and pass the body to it. So now we are 100% sure that the username exists and valid, and the password exists and valid as well. Now we have to check that the username is unique in our database. So to do that, first of all, our username will not have any case. So if you enter your new username as test or as test or as test, they will all be the same. We will convert all of them to small letters, so we don't have any confusions. And because when the user will log in, he will not remember he have placed his username like this or maybe like this, so it should be case insensitive. To do that, we are going to get the old user, or let's call it current user, which equals to Knex with the users table. We actually did not import Knex, so we'll import it from the config with the users table, and we are going to check where the username, I am not getting any, okay, where the username equals that username and get the first one. Here we have a problem. Why? No value in scope. Yeah, because the username is actually inside the body. So we have to do something like that. Body.username. The problem is here, we did not check the case of the username. So we have to check that. So I'm going to convert this where condition into where row. So I'm going to use a row query. And to use that, or to use the row query, I am going to use a very important function is in Postgres, which is the lower function. The lower function with Postgres will, as its name, will convert anything to lowercase letters. So I will get the lower username equals lower, and I will use the binding. It's very important that you do not pass any user input directly. So it's very wrong to do something like body.username like that. It's really wrong and it's really dangerous, and it will you will be vulnerable to the SQL injection vulnerability. So we are going to use the binding. So for each question mark, we have to pass an array with the parameters, and we have the body.username. So actually in here, we are checking where the username, the lower username actually equals the lower of the username that we actually have from the user. So now, if we have a current user, that means that the username exists in our database, we are going to throw a new HTTP error, but we have to import it at first. So I'm going to import HTTP error from HTTP errors, and I'm going to throw a new HTTP error.conflict, and username already exists. That's it. Now, if the user is valid or the username is valid, I'm going to go to the user to create a new user, and this user will equal to await Knex on the users, and I'm going to insert the following. In here, I'm going to insert the username, which is body.username.to lower case, to convert it to a lower case. And I'm going to insert the password as body.password. Then actually we need the user that we inserted to the database so we can know the ID of the user. So we are going to use the returning so we can return everything. Or we don't return everything. Actually, we only need the ID and the username from the user. We don't need to return the password. And that's it. But do you remember that I told you before that the insert function will return an array? You can see in here that it's actually an array. Those are the function of an array, not the functions of a user. You have the length function. So I can actually convert it, take the first index by putting them into those brackets, and then I will take the first index. So as you can see, I won't reach the point of taking the first index until this promise is executed. So now you can see the user parameters are solved. We have an ID and a username. Now we will return the user object that we got, and that's it. But as you can see in here, this is a very wrong way of storing passwords, because in here we are storing raw passwords in the database, which is really unsecure, and you should never do this during your development. You should always hash the passwords. So in the next video, we will learn about password hashing and how we can safely store the passwords in our database. So see you then. So in the previous video, we finished the register function and the login, and we started with the login function, but we did not implement it yet. So the problem is that we are going to store the password as a raw password, which is a big security vulnerability to our database or to our application, because anyone who will have any access to our database will know all of the user's passwords and can easily log into any account, and we should prevent this. We will use a way called hashing, is that we are going to hash the password into a random set of characters, and we are going to do that by installing a new library which we will call bcrypt, bcrypt.js. So after this package is installed, we are going to create a new config file, and we are going to call it encryption.ts. In this file, I am going to import bcrypt from bcrypt.js. And as you can see in here, we have to import the types. So I will copy this one and paste it in here and import the types. Then the error will go away. Now in here, I have two important functions. The first one is hash a password. And then second one is, why is this one is not working? Okay, now it's working. The second one is compare password. This one will take a password, which is a string, and a hashed password, which is also a string. Okay. So to explain to you how hashing and comparing passwords works, I have two very good examples, or a very good pictures that we can check. So the hashing is when you have any word, which is, for example, strawberry, banana, kiwi, you will pass it through the hash function and it will return a big hash to you. This hash, you can actually store it safely in the database, because from this hash, you can't possibly know the original password. So I will convert strawberry into this weird hash, but it's impossible to know what is the real password of this hash. So if a hacker acquired all of our database and have a list of all of our hashes, it's impossible to reverse engineer it and take the hash, convert it to a raw password. You can only go one way, which is a password to a hash. You can't go from a hash to a password. So the important question in here, how can I know when the user tries to log in is that his password is correct. For that, I'm going to go to the second picture. So for example, this is the bcrypt. So it will take a password, hash it, and this hash we are going to store in the database. Now, the second time that the user wants to log in into our system, we will take the password, hash it again, and we will have a hash. We will take the old hash from the database that we stored earlier, and we are going to compare them. If the hashes are the same, that means that the password is correct. So actually going to our first picture, every time that we are going to hash strawberry, we will have the same hash. So if the user, the first time his password is strawberry, and we stored this hash, second time when he enters his password strawberry, we will hash it again, compare those two hashes, and if they are identical, that means he's okay. If they are not identical, that means that the password that he entered is incorrect. But it's impossible to know the original password from this password, and that's why it's safe. So going back to our application, the hash password, the way that we hash password is very simple. First of all, we have to generate a salt, which we will hash with it. So to generate a salt, which is a random script, we are going to bcrypt and generate a salt. This salt will take rounds. As you can see in here, number of rounds to use. Default is 10. Actually, it's advised in here that you change the salt number to a number that is other than 10. So to do that, we are going to place our salt rounds into the environment variables. So we are going to go to our inf file, and we are going to store something new called password salt rounds. I am going to leave it as 8. So now we will go to our encryption encryption config, and here I will define the salt rounds, which is a number from process.env.password salt round. Now I can easily use this salt round in this gen salt function. Now I have a salt. You remember in this picture, to hash a password, we required a cost and a salt. So we have the salt. Now, what's left is for bcrypt to hash my password. I will pass my password and the salt that I generated. And that's it. Now, to compare the password, it's even simpler. I have to remove this because it's a one-line function. And I will call bcrypt, and there is a function called compare. I will give the original password and then the hashed password. And as you can see, this function will return true or false, a promise of Boolean, as you can see. So it's actually pretty simple, but I wanted you to know the logic behind it. So the final thing that we have to change in our database is in our register function, or not in our database, in our service, in our service, in our register function, instead of storing the raw password, we are going to hash our password and pass the body.password to it. But actually, this function is an asynchronous function, so we have to await before it. Now, let's go to our main function and try this function. So we will go to here and register a new user. So no, this is not the register function that we need. We are going to get it from our services. And we are going to pass the username as test and the password as 123, password as 12345. And we are going to get the user and print it as well. Now let's try it. We will first go into our desktop to open our pgadmin to check the results on the database. And let's validate what we have done. So now pgadmin started. We can write our root password, which you all know, which is root. Now we will open our server. We will go to our databases, URL shortener, schemas, go to the tables and to our users tables. And we are going to select all of the rows. Now, as you can see in the database, I have two items or two. I did not select the users. I select the URLs. I will select the users. And as you can see, I have two users, but with plain passwords, which is very bad to have. So now from my application, I'm going to create a new user and let's see. So I'm going to save the file, npm start. Actually, there is a problem in here that I noticed that I did not await for this one. So this one is actually a promise, not the actual user. So in here, I have to await and that's it. npm start. And let's see. As you can see, the database is not connecting for some reason. So let's check it out. So actually, you remembered when we changed our port, we did not correct it again. So we will exit, clear our terminal and run again. So let's see the results now. As you can see, username already exists because we have a username called test. So let's try another thing. And as you can see, conflict error. Everything is much more explained right now. Let's call it course. And let's try. As you can see, we inserted a new record, which is with ID 4, and the username is course. And as you can see, it's small letters. Although we provided it as capital letters, it's small letters in here because if you remember, we are passing the username with 2 lowercase. Now let's check our database and rerun the query. As you can see, this very long string is our password. So this is actually the password, the hashed password. And the next time that the user will come to our database and will try to log in, we will hash his password and then compare it with this one. So I will continue in the next video, so stay tuned. Hello again. So now let's continue and write our login function. First of all, I am going to remove those lines. I'm going to stop my application first of all. Going to clear my terminal. I always like to do that to organize my thoughts. Remember my password that I have placed for my user, because once I remove this line, I won't be able to restore my password at all. So that's why in websites, you don't have restore my password. You have changed my password because no one actually knows what's your password unless it's you. And you can validate your password by hashing it again, but you can't possibly know what is your password. So my password is 123456. So memorize it, please, for me. Now I'm going to remove this one. I'm going to go to my users service and go to my login function. So first of all, we have to do the login validation. So we have to validate login. It's not an async. We have a body, which is a request body. We have a validate body. We will pass the user body for it that the user passed for us. And the schema in here is pretty simple. We don't have to validate the username length or the password length because it's a login. The user will be validated in the register, but he can enter whatever he wants in the login. So we have the body. The username is actually, what did I miss in here? Did I miss anything? No. I have missed something. I don't know what it is. Yeah, because I have opened validate body twice. So in here, the username is string and required. And the password is string and required. That's it, nothing more. I won't validate anything more. Now I will go to my login page and validate my login. I will pass the body again, and that's it. Now I have to get the user from its username. So actually it's the same logic that I did in here. I have to do it again. So it's a very bad idea to repeat this same logic twice. So what I'm going to do is that I'm going to create a new function called getUser. That is an async function that will take a username, which is a string, and will return the user for us. So we are going to copy this exact function and place it in here. And we'll replace this one with this one. Then in here, I'm going to call getUser and give it the body.username. As you can see in here, I don't have to put this one, because have you noticed that I copied this one to here? So actually the caller function will await. I don't have to await in the same function, because if we copied this function in here and put it, you will notice that there is two awaits. So only one await is required. So I don't have to put another await. It's a tip that you have. It's useful to use it. Now, this function is okay, so I can use the same one in here. So I will check the user, await get user, and I will get it from the body.username. This will automatically check if the username is lowered and so on and everything. So if I did not find the user, I will throw a new HTTP error, which is not found. User name or password are incorrect. Okay. Now we have to check if the password is valid or not. So we will do that by checking if the password match by awaiting for compare password, the function that we wrote. We will provide the body.password, which is the raw password, and then we are going to provide the hashed password, which is stored in the database, which is user.password. Then, if the password did not match, meaning that we hashed this password and it does not match the hashed password, that means that the password is incorrect. So we are going to throw a new HTTP error, which is unauthorized, and username or password are incorrect. Actually, in here, it's better to put it also as unauthorized, because we don't know the user to know whether the username is incorrect or the password is incorrect. It's better to leave the user in these situations with the least possible information. Okay, just username or password are incorrect, go figure it out yourself. We don't have to worry about that. And then if everything is okay, we will return the user. And that's it for our login function. So now, although we have logged in our user, but we did not provide any token for the user to talk to us. So usually when you authenticate someone, you should give him a key. You should give him a token. You should give him anything. So next time you can recognize him. We don't want the user to log in every time. So we have to provide a key or a token. So in the next tutorial, we will learn about JWT, JavaScript Web Token, and how we can issue them and how we can authenticate user based on them, which will be our last part in our service layer. And after that, we will move to the final layer, which is the view layer. So see you in the next tutorial. So hello everyone. In the last tutorial, we finished our register function and our login function, and we hashed our passwords and we compared them. But the thing that is missing from our application right now is that the login function does not mean anything. So the user provides a username and a password. So what? We should provide the user with some key or some authentication token. So the next time the user is trying to get some resource from us, we can know who is this user. Is this user allowed to access this platform or not? Because if you remember, here we require the user ID. In the URL service, we require the user ID to access this function, because we have to check if the user that created this URL is the same user that is trying to access this update URL function. To do that, we should provide, or we should come up with a way that we can actually know and authenticate and identify the user. So to do that, we are actually going to use something called JSON Web Token. As you can see on the official website, actually it's pretty good. JSON Web Token is an open industry standard for representing claims securely between two pairs. What does that mean? So what does that mean is that whenever the user tries to log into my platform, after I authenticated the user, so we will go to our user service, we will close all of our tabs to clear our minds, and then after the user is authenticated and the password is correct, the user is correct, and everything is fine, we can actually provide this random text to him. But what is this random text actually means? So this random text, or the JWT token, consists of three parts: the header, the payload, and the signature. So as you can see, the header is explained in here that we have two things in the header. The first one is the algorithm that we used to create this JWT. And the second one, we are mentioning that this token is a JWT in fact. In the payload, we will store all of the user's relevant data. So in our case, in the payload, we will store the user ID. So the next time that the user will provide this token to us, we can check the payload of the JWT and know actually who is this user. The final thing is the signature. So the signature will guarantee that your server is the server that generated this token. So the user won't be able to generate this token by himself because your server or your application will sign it. And no one can sign a JWT token besides you. So when you receive a token on your application, you should verify this part, which is the signature. If it matches the key that you have in your server, that means that this token is valid. And this content of the token, the content of the tokens are valid, and this token was issued by your server. So let's see how we can implement the JWT in our server. So now we will go to our application and install the library that will help us to generate JWT tokens. So we will do that by executing the following command: npm install JSON Web Token. And we will wait for it to install. After we installed the library, we will create a new config file and we will call it jwt.ts. In this jwt.ts, we will configure our JWT instance to sign and validate JWTs. So we will start by importing JWT from JSON Web Token. As you can see, we have the same error. We have to install the types. So we will install them. It's not pasting. Why it's not pasting? We have to copy it. So now we will wait for it. So now after we installed the types for JSON Web Token library, we have to create two functions. The first one is to generate token, which is an async function that will take a payload. And this payload is actually an object. So we can refer to it as we referred to the object before, which is an object. The key is string and the value is any. Then it's actually pretty simple to create a JWT. We will call the library jwt.sign. And as you can see, this sign function will take three parameters. The first one is the payload, which we already have. The second one is the JWT private key, or the key that we will use to sign our JWT. Remember when I told you that there is a key that you will sign with it and you will validate with it? It's actually a random set of characters that we will choose as our secret key. So there is no specific criteria for it. So I will leave it as an empty string for now, and we will get back to it later. So in here, it's the options for this JWT. So actually there is so much configurations for the JWT, but the most important one is expires in. So this expires in defines the lifetime of the JWT. So we can issue the JWT for 1 day, 10 days, 1 month. I will make it a long lifetime JWT and I will put it as 1 year. So it's 365 days. Now we should specify our JSON private key. So remember how I told you that every secret should be stored in the environment variable only? So we will go to our environment variable and define a JWT private key. And I will set it to any default value that I like. So it's literally a random characters that I just pressed. And that's it. Now I will go to my JWT configuration and declare the JWT private key as process.env. the variable that I created, and I will cast it to string. Then I can easily use this JWT private key in here. Now, the second function that we should do in this configuration file is to validate the JWT. It's an async function that will take a token, which is a string, and then in this function, we will try and catch. In the try and catch, we will start by using the function verify. So JWT.verify, and as you can see, this will take a token and JWT private key. So as I told you earlier, it will check that this signature is valid, that the content of this JWT was not changed, and you as a server, you issued this token. This will be verified by knowing this secret token. So if you have this token, you can generate the JWT and you can validate it. And no one can generate a JWT unless they have this exact key. So actually this function, if it executed correctly, it will return the content of the JWT. So this function will actually returns the payload for us. So now going back to our code, those content we have to return to know what are the content of the JWT, because when we generate a token, we will store, for example, the user ID in it. So when we decode this JWT token, we should know who is this user so we can authenticate him. If anything happened during the verify function, we will throw a new HTTP error, which we should import from HTTP errors. And this HTTP error will be, for example, unauthorized. Please provide a valid token. So in here, as you can see, the contents are payload, JWT payload, which is an object, and everything is good till now. So now the only thing that is left for us is on the login function, instead of returning the user, we will actually generate a token for the user. So we will generate a token by calling generate token. This will take the payload, which we will store in it the user.id. And that's it. By that, we will have a valid token for that user. Now, instead of returning the user, we will return the user and the token. So he can knows the attributes of his account and also use the token for authentication. Now, let's try our login function and let's go. So remember how I told you to remember my password so we can log in with it? So now it's the time. So let's call our login function and let's pass the username as course and our password as 123456. Why it's giving me an, okay, because I missed this. So we will store it in a user, and then we will log this user to the terminal. And let's see the output. I keep typing yarn. It's npm start. So as you can see, we have successfully logged into the system. We have our user object, which contains the ID, username, and password, and we have the token. So in here, it's not advisable to send the password, the hashed password, although it's secure and no harm will happen from sharing it. You should not share it. It's not advisable to share it. So to do that, we will go to our login function, and in the user, we are going to do something like delete user.password. This will give us an error because the type of user is user. And by deleting the password, we are changing the type of the user. So it's not advisable to do it in TypeScript. What we should do is we will provide the required attributes only. So we will provide the ID, which is a user.id. We'll provide the username, which is a user.username. And we will provide created at, which is user.created at. And the final one is updated at, which is user.updated at. This is a more secure way to do that. So if we refresh our application, you will see that we have ID, username, and created at and updated at. The only thing left for us to do is that we will copy this token and we will run it through our validate JWT token. So let's see the content or the content of this JWT. So instead of copying the content, let me take it from this result, from this user object that the login function is returning to us. So I will call it results, and here I will print validate JWT. I will pass the results dot token, and that's it. So we are taking the token and passing it through the validate JWT token and waiting for the results. So let's see. As you can see, we have received the content of our JWT. So we received that the ID is 4 because if you remember, when we generated the token, we provided only the ID. So we have the ID as 4, which is correct. 4 is the ID of the users that we created. We have issued at, so we can know when we issued this JWT token. And the final one is when does this JWT expires. So we specified in the JWT config that it will expire after 1 year. So by this, we covered the JWT tokens, we logged in and received our token, and we validated the content of our token. So let's try and let's take this exact token, and for the sake of the experiment, I will remove this and I will change one simple letter with this token. So let's see. So this E, I will convert it to A, and let's try and see the output. As you can see, we have an unauthorized error. Please provide a valid token. So even a minor change will change everything in that, will make you unauthorized. So I hope this one was clear. And in the next video, we will wrap up our service layer and we will move to our view layer. So see you then. So hello again. In the last tutorial, we finished our controller layer in the MVC pattern. So our controller layer is referred to in here in the services folder. We finished our URLs service, and we finished our users service, and we finished also our visits service. We had a look at validation and how we can validate the user input. And we also looked at how we can throw errors efficiently from our application. We also had a look at encryption to hash the passwords, and we also had a look at JWT, how we can issue them and how we can validate them. So now we will move from the controller layer into the view layer, the layer that will connect our application to the internet, that will present our application. For this tutorial, we will present our application through REST APIs. And to do that, I am going to use a library called Koa. So if you are familiar with Node.js, you most probably already knows Express. Well, Koa is written by the same team as Express, but it's smaller and more expressive and robust. They also include the async support natively inside of Koa, while Express don't support async functions. They only support callbacks. And callbacks is really, it's very painful to deal with callbacks. Koa does not have in its core any middlewares or any routers or anything. So you have to install this separately. So to start with Koa, we are going to install a couple of dependencies that we want. So we are going to npm install, first of all, Koa and Koa body parser, which will parse any request body into the request body inside of the request. Then we have to install Koa helmet, which is a very important security library for Koa. We are going to install at Koa/cores to enable cross-origin resource sharing, and finally Koa Router, and we will install them. So we will wait for them to install. They won't take that long, I think. Because after that, we have to install our def dependencies, which is like, it's not the funniest part because their names are actually tricky. So I will leave, actually, of course, I will leave this install command in the description so you can copy it from here. I will be installing Koa types. So at types/Koa, I will be installing types/Koa__cores because we have a library called Koa cores without the at, so they had to add 2 underscores in here. I have to install also /types, /Koa__router, and we have to install types/Koa body parser. And I think that's it. We don't have to install anything else because Koa helmet have its definition actually. So let's install and see if we have any errors. So as you can see, there is no errors and everything works okay. So to start with Koa, we will actually start with the foundation in our index.ts file. So we will start by importing Koa as a capital letter. So we will import it from Koa, and we have a typo in here. And that's it for now. Let's create first the app, which is a new Koa app. And here, after we connect it to our database, we are going to start our Koa app. So we can do that by executing app.listen, and we have to give it the port. But remember how I told you that your application should not change its source code at deployment? So what if I specified the port as 3000 and I have to deploy it on a machine that the port 3000 is already reserved? So we have to put the port in our environment file. So we will do that by defining a port, which we will set for now for 3000. Now in here, we are going to specify this process.env.port. And then, actually we can do that, or we should pass it as an object. I think we should pass it as an object. Let's check together. No, we can't pass it. So we will pass it as process.env.port, but we have to cast it. So number, and that's it. The second parameter that we can pass is the callback that will be called when your server basically starts. So we will log server started with port, and we will add the port, which is process.env.port. That's it. Now let's try and run our application. No, I keep writing yarn. So npm start, database is connected, and it's asking for permissions to run on port 3000. So I will give the permissions. And as you can see, server started with port 3000. Now we can do a little test, and actually in Express, you can do something like app.get. But here Koa comes without a router, so we have to plug a router with it. That's why we installed it separately. We can use middleware, a raw middleware in here, and the middleware in Koa actually is pretty simple. It's an async function that will have one parameter, which is the context. And inside of that context, I have access to the request, response, and everything that I might need within the request. For example, the state. Now, let's write a very simple middleware that will take the request and return the request, the context, response.body, Yusawi, hello world. And let's try it. So our application restarts now. Let's go to our browser, localhost 3000, and that's it. As you can see, I have received hello world in here. Now we can go and continue configuring our Koa server. So the way that Koa server works is that we have a second parameter in here called next. So let's demonstrate. So I will create another middleware, and I will call it, I will not call it anything. You can't call a middleware, but I will define another one. And this middleware, instead of doing something to the body or passing the body, it will actually just put something in the context state, which we will call, for example, user ID equals to 10. Then it will call and await for the next function. That's it. Then we will log something in here that middleware 1 finished. Then I will do the same thing here, console.log middleware 2, and then I will log the context.state.user ID that I have already placed in here. Then I will go to the context.response.body equals to ctx.state.user ID. Let's try it. Now, if we go to our browser and refreshed, you will see that the results are 10. And if we went to here, you would see that middleware 1 finished, which is this one. Then middleware 2 started and printed 10, which is the value that middleware 1 have placed. So each middleware have two options. Either this middleware will call the next function and will pass the control to the next middleware, or it will not call the next function and return the response to the user. So this is the idea of the middlewares. So now there is a pretty good part or a number of different middlewares that we are going to use. The first one is the cores middleware. So we will import cores from @Koa cores, and we will import helmet from Koa helmet. We will import body parser from Koa body parser, and that's it. Now, first of all, we have to enable cores. What is actually cores? Cores, it's cross-origin resource sharing that will allow any website to use your APIs and benefit from it. So we will enable it because by default it's blocked. Then we are going to use helmet, which will provide a number of a protection against a popular security vulnerabilities. So if you can check in here, helmet actually protects you from all of those security vulnerability in your application. So with a single line command, you are protected from all of those. So it's recommended to have it. Then we will check body parser, which will pass the body of the request into this one. I will show you. So if we created another one, let's call it CTX. So actually the body of the request will be in here. .request context.request.body. So the body parser is actually setting this value into the actual value that the user provided. So it's very helpful to have it. And the final middleware that we will learn about is a custom middleware that we will write in our next tutorial. So bear with me. So actually, the last middleware should be the error handling middleware. Because if someone is already familiar with Express, you already know that we should always create an error handling middleware because we are throwing exceptions all over of our application. So someone should catch them. Otherwise, our application will crash and we have to restart it. But the beauty about Koa that if we went to the official documentation and we scrolled down and we searched for something called error handling, you can see in here, like by default, outputs all of the errors unless app silence is true. The default error handler won't output errors when error.status is 404. So basically that means that if there is any error with a status code, it won't output it. It will handle it internally. Let's check our library that we are using, which is HTTP error. And let's try to store this exception in a variable, and we will call it E. And let's see the content of this E. As you can see, there is an expose false that we don't want to expose this error. There is a status and there is a status code as well. So the library that we picked, actually, it's pretty perfect for Koa because Koa internally knows about this library and will handle it for you. So let's try an example and let's go to our index.ts. So in this middleware, I am going to shorten a URL. So I am going to basically write my first route. So context.response.body will be equals to await create short URL. Now I have to provide the body, which have a URL and an ID. So we will pass it as context.search or .params, no, .search, or we will call it .query. What does that actually mean? The query is actually get past query params. So you have two types of params basically. You have the get queries or get params, and you have the post body. So we are actually here interested about the get params because this is actually a get request because we are using a middleware. And the second parameter will be the user ID. We will pass it as for. Here it's telling you that URL is not mentioned. So I just have to cast this to any to remove this error because we will handle it in a different way. So I will go to my browser. First of all, I will run my application and I will go to my browser and I will just refresh. So as you can see, I received the correct error message. Oh, sorry. I received a correct error message that the URL field is required. And as you can see in here, nothing got printed on the console. Let's try a different thing. I will comment this one and I will throw error as we were throwing them before. Is required. And I will refresh. And then let's go to our browser and refresh. As you can see, now we have an internal server error. I will keep pressing this button. Now I will have an internal server error. And if I go to Visual Studio Code, I will find the error is printed because my application actually might crash because of it. So it will print the exception for me. So now you can see more the benefits of the library that we actually used. So now if I uncommented this, and if I tried to go to my browser and pass a URL parameter, which is, let's call it a URL, and I will shorten Google URL. As you can see, I received again an internal server error because relation URL does not exist. What does that mean? So let's investigate. So actually the error in here is that we have a typo in here, because in here we tried to insert to a table called URL instead of URLs. And because we haven't tested our functions before, we did not know about that. So as you can see, we received an internal server error, and our error got printed on the screen because it's actually an important exception that we should know about. So let's refresh our application, restart it, and let's try again. I will refresh again, and as you can see, I received a random ID for my application, for my URL, which is this one. And this is the URL, and the user is 4. So everything is working perfectly. We have our error handling method working perfectly, and we solved a very critical exception in our application. So now we can move actually to the next step. So now I will remove this line, because we don't need it. Koa actually handles all of the error handling for us. We don't have to do anything. And we have to start with our Koa Router. So to do that, I will create another folder, which we'll call routes. And in this folder, I will create index.ts. Inside this index.ts, I will import router from Koa Router. And I will create a router, which is basically a new router. Then I will export default this router. As you can see in here, this router will have all of the known functions: the get, the post, delete, and put. So it's actually what we are used to. So far, so good. Now, let's write a specific route. We will call it /hi, and this is actually the same syntax, context, and I will pass context.response.body equals by. And let's try. So how we can use this router in our Koa application? We will use it by doing the following. First of all, I will import my router. So I will import the router from routes/index. Then I will use my router as a middleware. So actually the router will expose two middlewares. The first one is router.routes, which will expose all of the routes. And the second one is router.allowed-methods. So for example, in my allowed methods, what's the problem with the allowed methods? Let's check. So yeah, sorry. So I should use it in a different middleware. So I should do something like that. To .use router.allowed methods, like that. It's not with a comma. What does this allowed methods actually use or actually do? It will return a not supported exception if they, for example, provided /hi but with a post request. So it will provide a nice interface for our API. So now let's restart our application and let's go to our actually this one will not work because it's not found. We don't have a URL at this path. So what we are going to do is that we are going to call /hi that we already specified. So as you can see, the response is by, which is exactly what we did in our router. So we are ready to go. We will clear this router, and in the next tutorial, we will start setting up our different entities routers. So see you in the next tutorial. Hello again. So we will continue on our router subject, and we will start creating the routers for our entities. So the router will have actually a use function, and this use function is used so that the router can actually use another router or another middleware. So we are actually going to define 3 important middlewares. The first one is the auth middleware, which will define login and register. The second one is the URLs middleware, which we can shorten a URL and update a URL and so on. The final one is the visits router, which we can get like the latest visits and visits for a URL or for a user and so on. So for each of those lines, we have to create a separate router. So we are going to do that by creating each router in a separate folder to keep things organized. We will start by the auth router. We will do as we did before. We will import router from Koa Router. We will create the auth router, which is a new router, and we will export default this auth router. Then we are going to use this auth router in here. So we are going to import it, .routes, as we did before exactly, and auth router .allowed methods. So actually what got me confused is that, remember in the last tutorial I did the same exact syntax and I had error in here. So that's because in the app.use, each middleware should be in a separate function. So this function won't accept 2 middlewares, the use function. Where in the router, the router can actually accept multiple middlewares on the same line. So that's the difference, to not get you any confused. So now that we have introduced our auth router, we will start by implementing the required functions for that, or the required endpoints for that router. And to do that, we have 2 important endpoints. The first one is a post endpoint, which is register. And the second one is a post endpoint, which is login. And for each one, we will add the middleware, which is this one. And for this one as well. So this is the beauty of the MVC. Remember how we spent a lot of time on the register function, controlling the input, controlling the output, validation, and so on. Now we can easily do the following. Context.response.body equals await for the register function. And this register function, not this register function, I keep importing the wrong one. So be careful what are you importing. My register function is from the services. This will take only a body. And I can easily pass that context.request.body. And I only have to cast it to any because I already did the validation. That's it. That's everything I should do in here to implement my register endpoint. And this register endpoint will take a username and password, validate everything, check everything, throw the required errors, if any, insert it and return it. And I don't have to worry about this. This is the beauty of splitting your app into 3 separate and different layers. Then in here, it's the same exact thing. Context.response.body equals await for the login function, which will take also a body. So see context.request.body as any. That's it. Nothing more. please note that here I'm using context.response because I want to set the body for the response. And here I'm taking context.request because I want to take the body of the request. So keep that in mind, please. So now, if we want to try those two endpoints, how can we do that? We can do that by actually installing a very important tool called Postman. And we are going to install it together. So I will go to install Postman, then download it for Windows. Maybe I have it, I don't know. Yeah, I have installed it before. So installation process is very easy. After you install, just open it from here. No, I have deleted it for the tutorial actually. So I will install it with you. We will open it. We will open the installer and we will wait for it to open. And now it's open and that's it. The installer is actually portable. So we don't have to install everything. That's why I didn't find it. So let's start our application, clearing the terminal, npm run start, and let's try to register a new user. So we can do that by actually going to the Postman and selecting the request type as post and adding the URL http:/localhost on the port 3000. So now we have a not found response because we don't have anything defined at this endpoint. So remember how in our index function we used the router, and in our router we used /auth, then we used the auth router. In the auth router we used /register. So we can't do something like /register. We don't have this route. We have /auth/register. And let's try it. As you can see in here, we got two error messages. The username field is required and the password field is required. This is the validation that we actually placed in our users function, in our user service, in our register. So let's try and add a body to it. So we can add a body to our request by going to the body and selecting a row body and then selecting a JSON format. And we will open the curly brackets. We will set our username as test3. And for example, our password would be 123. And let's try it. As you can see, the password must be at least 6 characters. So we are going to make it longer and let's try. So as you can see, we received our ID and our username. Now let's try to log in with this user. So the username is test3 and the password is this one. So we actually don't have to change the body because it's the same. We will just change the URL to be /auth/login. And now let's try it. We will send again. And as you can see, we received our user object and we received the authentication token, the JWT token that I told you about it before. If we missed our password and send the request, we will get this error because the password is required and we did not pass it. So we will try a wrong password. And as you can see, username or password are incorrect. I have to get it to your attention that if you are checking in here, the status of the response is actually changing. So this one is 401 unauthorized because the username is invalid or the password are invalid. But if I remove the password, you can see that the status is 400 bad request. So this is actually the best practice to throw exceptions and to handle them in your application. So now we have finished our auth router and we have to deal with our URLs router and with our visits router. So let's do that. Hello everyone. So now we have to start with our URLs and our visits routes or endpoints. So we will start by creating our URLs routes file, and we will start by importing a router from Koa Router, then creating URLs router as we did before, and export default for the URLs router. Then we are going to go to our router and use our URLs router dot routes as we did, and URLs router dot allowed methods. Now we will go back to our URLs router, and I will stop my application to not disturb me or distract me. Then we will start by defining the routes. The first one is URLs router.get. That would actually get me all of the URLs for my user. So it's actually, we will have the context. So context.response.body equals await get URLs, and we will pass the user ID. But how could we know the user ID? We don't have this information in here. So apparently, we should have some way of protecting those two routes, so no unauthorized user would access them. And that's because those functions actually require the user ID. So I should first identify the user and then prevent any unauthorized user from accessing those routes. So how can I do it? So actually we can do it by introducing a new file called middlewares.ts. This file will hold all of the specific middlewares that we are going to provide. So the first function that we are, or the first middleware, it's actually one middleware in this application that we are going to define, which is require auth handler. This middleware will have one job, which is to validate the token that the user will provide. So we have the context, and just to define some typings, we are going to get the type of this one, which is a router context. And the next function, which is a next function, we can import actually this interface from Koa. So we can import from Koa the next function, so we can have correct autocomplete. So what does this function, what will actually do? So first of all, we have to get the current token. So the current token will be sent to us via the authorization header from the user. So we can access the headers by accessing the context.request.headers.authorization. So how will the user send us this token? So usually, let's start our application. Let's solve this one. Let's start our application. And I keep writing yarn. So let's start our application and let's try to log in to get a token. So let's log in. Okay, now we have our token. So actually the way that the user will send the token to us is via something called barrier token. So in Postman, we can make this authorization by selecting barrier token and pasting the token as is. But if we went to the headers section and let's see the hidden headers, as you can see, Postman added the word barrier to our token and then a space and then added the token, which is a very common practice when passing an authorization token. So what we should do in our application, now that we have acquired the token, the token contains of two parts. The first part is the barrier keyword, and the second part is the token itself. So first of all, we have to check if the current token does not exist. We don't have a current token. We will throw a new HTTP error that we will import HTTP error from HTTP errors, and we will throw new HTTP error which is unauthorized, and we will say in the message, please provide a token. Then if we have a token, we should take the actual token. So the actual token without the barrier. So let's take this and call it the header. Let's call it the header for now, because it's not actually the token. The token is a different thing. So the token is actually the header that we are going to split with a space and take the first or the second index. So if we have this string, we are splitting on this space and then taking the index 1, which is the actual token. So this is our actual JWT token. Now we are going to take the token payload, which we are going to pass through our validate JWT token. So await validate JWT, and then we are going to pass the token. Then after that, we have actually in the token payload, we have an ID, which is our user ID. Now we can easily set context.state.userid equals token payload.id. Actually, let's check why this function is returning. What is the return type to know why we are getting this error. So actually, to be honest, I don't have an idea. It's probably because the JWT payload have to be casted to something else. Because it can actually be a string, so we are going to cast it as you remember before, we are going to cast it as this object, because it's actually key value object. Our content will never be a string, so we are casting it as this object. So now when we go to our middleware and check the ID, we can find it inside. So now we have placed our user ID inside the state object, which should hold information about the user that is trying to access our API. And that's it from our middleware. We don't need to specify any more things. Now, the only left thing that we need to do in here is that we have to await for our next function. So the middleware will actually check our token, split it, validate it, and then add our user ID in our context state. So how can we use our auth handler? So it's actually pretty easy. Here, the router.use will actually take multiple middlewares. So even this string is actually a middleware that will check your URL against this URL. So it will check the first part. If it's auth, it will start with the next one. If it passes, it will go to the next one, and so on. So if it's not auth, it will go to the next one, which is URLs. And if it's /URLs, it will go to the next one, and so on. So in here, we can call the require auth handler middleware. And now we have a sequence. So if the URL started with auth, we will check, we will go through the auth router, and then we will check if it's register, we will execute this. If it's login, we will execute this. Then if it was not auth, it will check if it was URLs. So if it was URLs, it will first go through the auth handler and check the authorization token to prevent any unauthorized users from entering the URL's endpoints, because it's only for authorized users. Now in our URLs router, we can now actually write the following: context.response.body equals get URLs, and then we can pass the user ID, which is in context.state.userid. Note that in here we don't have to check if we have a user ID or not, and so on, because in our routes file, we can't go into the URLs router until the require auth handler cleared our path. So it's guaranteed that in here we have a user ID. The next thing that we have to specify is the limit and offset. And because this is a GET request, we don't have a request body, we have request query. So we will pass context.request.query.limit. But we have to cast this one because it's not casted, so we have to cast it to number because by default it's a string. The final one is the offset. We will cast as well, ctx.request.query.offset. And that's it. So as you can see, we finished our authorization middleware or authentication middleware, and now we only allow the authenticated user to enter. So we will test that in our next tutorial, and we will finish our URLs router and our visits router. So see you in the next video.